All right, good morning, everyone. It's 9:05. We're going to go ahead and get rolling. Welcome to Los Angeles. Welcome to University of Southern California. It's so exciting to be here. We were here 6 years ago before COVID. It feels like a million years ago, but we're happy to be back. But I'll go ahead and welcome up Robert Zubrin.
This is a moment of crisis and opportunity, although I have to say that the crisis part is looming a lot bigger right now. Okay, so yeah, it's a good news, bad news situation. Okay, the bad news is that the NASA space science program is under severe attack. Severe. This is not a small attack. The NASA budget is being cut by about $6 billion overall, and $4 billion of that is going to the quarter of NASA that is the space science program. This is the part of NASA that does the Mars rovers and orbiters and the probes to Jupiter and the New Horizons to Pluto and Hubble and Webb and the other space telescopes and all the Earth observation satellites as well. Okay, it is the part of NASA that since Apollo has been responsible for at least 90% of all NASA's real accomplishments. Okay, it is the purpose-driven part of NASA. So they're cutting $6 billion from NASA, and $4 billion of that is being directed at the best part of NASA, the very best, the part that makes it worthwhile. So this is really bad. Now, look, you know, they're talking a big game. Oh, we're going to the moon, then we're going to go to Mars, so don't worry about this. We had a similar situation in 2005, okay? And in many respects, this was one of the Mars Society's finest hours, because in early 2005, President Bush announced the vision for space exploration of going back to the moon and on to Mars, and this time to stay. Great, right? Okay. And simultaneously with that, his NASA administrator, Sean O'Keefe, announced, well, and we're going to destroy the Hubble Space Telescope because it's too dangerous to go up and fix it. Yeah, we're going to the moon and Mars, but it's too dangerous to go to Hubble, so we're going to destroy it. Okay. And the Mars Society, actually uniquely among all the space advocacy organizations, except the astronomers, but said, no, we're not taking this deal. Okay, first of all, if you don't have the guts to go to Earth orbit to save Hubble, you're definitely not going to the moon and Mars. And then, but beyond that, this is a crime against science. Okay. Hubble is the most productive scientific instrument in human history, okay, and they were going to destroy it, and they were coming up with ridiculous excuses like, oh, we're not destroying it, even though they were attempting to put out a procurement to deorbit it. They weren't just going to not repair it, they were going to make sure that it was brought down. Okay, okay, we're giving it an honorable discharge is what the head of the NASA Space Directorate said at that time. And I countered in print, pointing out that, okay, here's this thing, it's $4 billion worth of the taxpayers' property, about as much as it costs to make an aircraft carrier. And if the captain of an aircraft carrier said, well, the ship developed a leak, and I could have sent 7 volunteers below to fix it with a 98% chance of success, but we thought it was too risky, so we decided to abandon ship, he would not get an honorable discharge, okay? And so forth. And we turned that around. We ran O'Keefe out of his job, and the person who replaced him, Mike Griffin, said, oh no, we're going to save Hubble, and we did. Now, this situation is much more severe than that, okay, because this isn't just one program that is being destroyed, okay? So at the same time that they were abandoning Hubble, they were getting ready to send MRO. The Mars Reconnaissance Orbiter. We had just landed Spirit and Opportunity. We're building, beginning to build Curiosity and a bunch of other planetary missions. And so in this case, they're going after the whole program itself, not just one important part of it. And this can't be tolerated. Okay, now look, why should this matter? Okay, you know, say, well, okay, you're getting the moon with people on the moon and then humans to Mars. And what are you worried about these little rovers and things for? Okay, well, I'll get a little bit more to that. But first of all, I want to talk about how under the current situation, we're not getting the moon or Mars. Okay, Artemis is a total mess. It is a total massive mess because the same irrationality that is allowing this destruction of the space science program is disorganizing any rational human program. Look at Artemis. They've got 5 primary flight elements, okay? The SLS, Starship, the Orion, the Lunar Orbit Gateway, and the National Lander, and none of these things fit together, okay? Because none of them were designed as part of an overall system. They were each simply promoted as something pleasing to some constituency that wanted money. So each of these are not, this is not a purpose-driven program. This is a vendor-driven program, and it's totally chaotic, okay? Now, you could say, well, Starship can do it all, right? Because it doesn't need the rest of these things to do a complete lunar mission. Okay, and that is sort of true, except that if you do the Musk architecture, which is you send a Starship to low Earth orbit, and now you have to believe not just that Starship is going to work, which I do believe, but that it will achieve the performance metrics that are currently being advertised, which is a whole nother issue. Okay, but if you believe that it really could deliver 100 tons to Earth orbit, and it will weigh no more than 100 tons itself, then you have to launch 4 more tanker Starships to refuel the tanker in low Earth orbit to get it to the Gateway. And then you have to refuel it at Gateway with 3 more tankers, each of which require 4 more tankers to get them to the Gateway. Okay, so you end up with like 14 tankers to do 1 lunar mission. Okay, this is a wildly suboptimal mission architecture. And now you also have to believe that you can do these 14 launches within some limited amount of time. And, you know, it's a different universe. Now, so this isn't going to work. And then the National Lander, which uses hydrogen oxygen, is not compatible with the Starship, which uses methane oxygen. Now, if you had leadership at NASA, this technically could be repairable, okay? While no one can convince Musk to also build a smaller Starship, I have tried, I call it the Starboat. That's what is needed, something 1/5 to 1/10 the size of Starship that runs on methane oxygen, and you could then put a Starship in low lunar orbit and have it act as a tanker for a little Starboat that goes up and down. That would make sense, and you could use the same approach to Mars, okay? 2 sizes fits all. And so instead of landing the Starship on Mars and having to refuel it with 600 tons of domestically made methane oxygen, you'd only need 50 tons. That's for a direct flight from the surface of Mars back to Earth. You'd only need 50 tons to send the Starboat up to the orbiting Starship. And so you could have a 2 sizes fits all architecture, okay, but that would require leadership at NASA. However, the problem is bigger than that, okay, because some people say, well, look, it doesn't matter if NASA is destroyed because Musk can do it all, okay? And this is simply not true. This is not true. First of all, to realize the Musk architecture requires a multi-megawatt nuclear reactor on the surface of Mars. Where is that going to come from? Okay, the space nuclear reactors use highly enriched uranium or plutonium. These are controlled substances. It's going to require government involvement. If you try to do it with solar energy, with the architecture that he's proposed, it requires 13 football fields of solar panels and so forth, which is also not happening. So you need government cooperation to make this work. But there's a bigger issue, okay? Because you see, look, humans to Mars cannot be done as an Elon Musk hobby horse or a Donald Trump hobby horse. It has to be done as an American program. It has to be done with bipartisan support, or as soon as the fortunes of political war shift, it will be killed. Now, here's the thing. How do you get bipartisan support for this program? You make it not about Musk's desire to have a planet terminus on which a select group of scientists can go and be there to reconstruct human civilization after the Earth is destroyed. You know, this is his concept. Is he calls his colony Terminus after the one in Foundation. Or it can't be done to have Trump win his second Nobel Prize. It has to be done for purposes that are understandable by a broad part of the American electorate and political constellation, and that is science. Okay, if you mark this program with the brand of Cain by having it done by the same people who murdered the space science program, you're guaranteeing that it will be destroyed as soon as the fortunes of political warfare shift. Okay, Musk has defined himself in an extremely partisan fashion, and if this program is defined in this extremely partisan fashion, that will be its fate. On the other hand, if you said, instead of killing the space science program because we're doing this stuff, we're going to use this stuff to radically expand the potency of our space science program. That is, the first Starship landing on Mars, or Starboat, okay, instead of landing a Optimus Tesla mannequin for public relations purposes, it lands a robotic science expedition. You know, Musk says the Starship could land 100 tons on Mars. Let's give them 30. 30 tons is still a lot, because right now we can only land one, so 30 tons. What could we do with 30 tons of scientific payload landed on Mars? Instead of landing one rover, we could land 20. And instead of one little helicopter, we could have 20 medium-sized helicopters, each carrying 20 or 30 kilograms of scientific instruments. Okay, and we could have a well-instrumented science lab in the lander to which the rovers and helicopters bring back samples, and they could deploy light detection experiments and drillers and all sorts of things, and seismic networks, and everything that you could possibly want to do a science expedition to Mars that would be 2 orders of magnitude more potent than anything we've been able to do with the kind of science program that we've done up till now. So instead of making the human Mars program the murderer of the science program, we make it its enabler, its greatest friend. Okay, we can do, yes, that's what needs to be done. But if you're going to do that, instead of shutting down JPL and these other places that make things like Mars rovers and helicopters and such, you need to expand those capacities. All right? Because who's going to make the Mars rovers that would go on this expedition if you're shutting down that whole line of activity? So there is that. So now if you did that, then you turn so in other words, that's how you're exercising the Starship first to get it ready to send humans to Mars. And then you can send subsequent science expeditions, as well as expeditions which you're deploying construction rovers and stuff to access the glaciers on Mars and melt water out of them and fill up the Starship on the surface of Mars with propellant made there, using its tanks as your surface storage depot, and all the rest. This program evolves naturally from an expanded science program into a human program. And you see, if you do this, then you have the support of the Mars science community for this program. And the Mars science community is university-based, which is to say it's based in a social network that is the left of center and which has the ear of the Democratic Party. And then you have a program that has national support. And then instead of this program being a Musk hobby horse to create the Harry Seldon Terminus colony on Mars, it is a national program to once again astonish the world with what free people can do in science. Okay, and this is very important. Okay, because this is the larger issue. The highest ideal of contemporary Western civilization is freedom. And science is the child of freedom. Free inquiry, okay, is what produces science. Okay, the fruits of science is technology, and anybody can use that. But science itself, okay, comes from freedom. And I have to say that this administration its attack on the space science program is coming in tandem with an attack on American science much more broadly. The National Science Foundation, the National Oceanic Administration, the Center for Disease Control, the National Institute of Health. Okay, and in fact, in some respects, some of the attacks on scientific medicine by this administration are more severe than what they're doing to NASA, because at least they don't actually have a NASA administrator, but whoever is sort of doing that has not yet, issued a denial that the moon exists or something. Okay, which is sort of the case with medicine. But so we're having an attack on science, and once again, okay, if you look at the Enlightenment, okay, the proof given for the desire to set reason free was that it produces science. Science is the poster child for the value of human freedom. Okay, it puts it in terms that are not abstract at all. It produces stuff that saves your child from dying of disease. It produces methods of navigating the sea that can get you from here to there, okay, and enable global trade. It can do all these things. This is what science can do. Science is magic that works, okay, and it's a product of freedom. And now, admittedly, space science is not all of science, but it is the greatest symbol of science in our age. It is the banner of science. It is for the scientific worldview what Gothic cathedrals were to the religious worldview of the Middle Ages. Those were represented concrete symbols of the value that those societies put on their highest ideals. Okay, of human salvation through the grace of Christ. Well, the NASA space science program has astounded the world with the things that it does. It is the images, Hubble, and the images from Hubble, and now from Webb, and taken of the outer planets and so forth by these various probes, and yes, from the surface of Mars. These are the Gothic cathedrals of our time. This is the banner of the scientific worldview. This is our flag, and they are burning our flag. That's what they're doing. They're burning our flag when they destroy this program, and it cannot be tolerated. So to save not just the Humans to Mars program, but to reaffirm the highest ideals and the most productive ideals of our society, we need to repel this attack, okay? And that is why the Mars Society in the coming period, and we're going to talk more about this, you'll hear about this from James, you'll hear about it at the banquet, okay, is going to be to mobilize, to contact Congress, to mobilize chapters in every district to go to speak to anybody in Congress or the Senate or who can reach them and say, this must not happen. We can't let them burn our flag, and we're not going to let them burn our flag. Thank you. I'll take questions.
I was wondering, so you were talking at the beginning about how we have this huge problem with compatibility between the systems of Starship and NASA. Do you think as the space kind of sector shifts from government to private, do you think we'll have more problems like this or less problems like that with compatibility?
Well, the problem that we have here is this, okay? The entrepreneurial space sector was launched in a serious way, in part due to NASA fumbling, okay? That is, in the 1960s, when NASA was storming heaven and Apollo, not many people were looking for a private sector savior to step forward. But then as NASA, in the following decades, got people increasingly frustrated with not being able to continue to act as we had seen it act before, then people said, this has got to be done. Someone's got to step forward. And at first, there were a multitude of efforts in the 90s, and most of these were undercapitalized and failed. But finally, someone came along who wanted to do it, who had the capital and business smarts to do it. Of course, that was Musk, and other people got into it in other sectors. And this has taken off. But the problem is, you see, is that it's a good thing that we're getting extra actors into this game besides NASA. It's essential, actually. Okay, but nevertheless, there has to be a NASA. Look, it is not true. There are people who are going around saying that the problem is NASA, let's get rid of it and let the private sector do it all. Well, there's about 200 countries on this planet that don't have a national space program, okay? And almost none of them have any entrepreneurial space program either. You know, if you're talking about sending probes to Mars or even the moon, it really needs a government customer. Now, these things can be implemented on behalf of the government customer much more efficiently by private enterprises. Especially if they are mission driven, the issue here is not to spend as much money on the program as you can and take as long as you can in order to distribute money to a district, but get it done as quickly and cheaply as possible in order to make a profit by saying we're going to do the job and here's what we're charging it, and then costing it less to yourself. And in aerospace, cost is people times time. So the faster you get something done, the more money you make if that how this thing is constructed. Now, I mean, look, there's problems in this. Okay, I've published, I mean, Mars Direct diverged enormously from the NASA line in the 90-day report. And, you know, I have argued that sample return should be replaced with a much more diverse program of sending small and medium-sized missions to Mars, helicopters, rovers, life detection experiments to lots of places. Instead of doing one $10 billion mission, let's do $2,500 million missions. It makes a lot more sense. So NASA does need to be fixed, but in order to fix it, we got to save it. Okay, and if there is no, and yeah, and Artemis, okay, is a failure on the part of NASA, because what happened with Artemis, okay, was they got excited about the progress that Starship was making. They said, okay, we want to be part of that. So they gave Musk his $2.9 billion contract to use the Starship as a lunar lander. And then the other team, the national team, Blue Origin, Lockheed Martin, yelled and screamed, he can't do that for $2.9 billion. And Musk's answer was, well, that's all I'm charging you. And so what's there to say? But then they yelled and screamed some more. And since they had influence, Congress basically forced NASA. They're going to hate you if you don't give them a contract. You better give them a contract. So they gave them a contract, but so NASA couldn't help that. But what they should have done at that point is said, okay, we're going to give you your contract, but this is what you need to build. Okay, you need to build a lander that is compatible with Starship. Instead of a hydrogen-oxygen, we want it to be methane-oxygen because that is compatible with Starship, and the Starship could then act as a tanker for you. And in other words, basically, they could have given them a contract to build Starboat. Okay, and that's more or less what NASA needs to do now. They have to basically say, look, sorry about that, but you want this contract, we got to have you build what we need. And management will say, okay. And that's what happened, but it's going to take leadership. And right now, there isn't even a NASA administrator. Okay, that is, I had hoped that, okay, you know, Musk gave $200 million to get Trump elected, and supposedly they were going to give him the ring of power, you know, the one ring to rule them all, and he could make all his dreams come true. But instead, he put them in power, and they said, sorry, Musk, you're a chump. The chump has done his work. The chump may go. Thank you for your 200 million. Now get lost. Now, and they got rid of Isaacman too. And then they didn't even, there's other people that could be a good NASA administrator who are Trump supporters, okay? But they didn't even put any of them in. So we have a serious problem here. Yes, we need to demand that, number one, that the murder of the space science program be reversed. And number two, that a competent NASA administrator be installed who can rectify the problems with NASA. Questions? Where was the person? Raise your hand. Yes.
What critical functions do you see government having that private commercial states cannot solve?
Well, things that go beyond short and medium term profit. Okay, so if we're talking about science missions to the Mars and the outer solar system, there really isn't a good business plan for that. Okay, but look, you know, but there is a real purpose for doing that. You know, okay, here's a quote. Okay, we are the watchers on the walls of world freedom. Who said that? Anybody know? I'll give you a hint. He also said, a new ocean has opened and free men must sail it.
Kennedy.
John F. Kennedy, yes. Okay. And by the way, he didn't actually give that speech. That's the speech he would have given that evening in Dallas before he was killed. Okay. But the point here is Kennedy believed, and I believe, and I think most Americans believe, that this country is something that stands for more than its own interests. This country stands for a cause. It stands for the cause of world freedom and the things that freedom yields, which include science. And so America, okay, literally from its foundation, Benjamin Franklin, but especially in the post-war period, in the modern period, we have raised the banner of not just freedom, but of science, which is and we've done this, and we've astonished the world with what what freedom can do, okay? And, you know, I was in Leningrad when we landed on the moon, okay? Because as a kid, I was a chess player. And let me tell you, it made an impression. It made an impression. And it made probably more of an impression lots of other places. But this is what we got to do. And, you know, there are people right now, okay, who say, America's the past. China's the future. They are efficient. They can coordinate everything. They have achieved the harmonious society by knowing what everybody does all the time, and all of that. And that's the future. And not this interesting but chaotic and failed experiment called America. And we need to refute that thesis. And yes, okay, we need to continue doing the kinds of great things that the space science program has done, and then follow that up by truly astonishing the world what free people can do by sending humans to Mars. Thank you. Okay, I guess that's it, right? Okay, which one? Not that one.
Okay, I now recognize myself for the next talk. I'm going to give an update on the Mars Society's political activities this year. And I'm going to start about a year ago. Robert and the board of the Mars Society Steering Committee, we meet every year. And last year, one of the directions was, let's grow the chapters of the Mars Society so that we can go do more political activities in the US. Now, just a reminder, the Mars Society is a global organization. We have over 1,200 members worldwide. We have chapters in over almost 50 countries. And in the US, We had at this time last year about, I'd say, 8 to 10 active chapters. The most prominent ones are Chicago, San Francisco, Seattle, where I live, and lots of activities in Texas, obviously. Well, we wanted to grow this chapter so that we could really have a huge base of members in the US that could engage with local politicians, that could, like our ambassadors, go out to local events and talk about humans to Mars, talk about the advocacy of what we do. So we worked on that as a team, the Mars Society. We appointed Ron Story, who was a very prominent chapter leader in Texas, to be our new director of chapters. And he got to work, and I can report as of today, we have about 15 new chapters in the US. We've already gotten some traction with talking to Congress people on that. Now, this year started, thank you. Thanks to Ron. And this year started, I got a call, my birthday is New Year's Eve. So New Year's Day, I got a call from Greg Autry, who is a huge ally of ours. Greg was the CFO nominee for NASA in the first Trump administration. We've been working with, he was actually our sponsor at USC back in 2019 because he was a professor here. And he called me, he said, I'm going to help with the transition team for NASA. I'm on something called the Doge team, which I didn't know what that was at the time. I thought the cryptocurrency. And he said, we'd like to invite you, James, to come speak at this meeting with all the incoming NASA transition team members from the administration. And we're going to invite the other nonprofit executive directors as well. So the folks like the National Space Society, the Planetary Society, Space Frontier Foundation, the folks like that. So I was in this meeting in January, and I got to say, number one, I was the youngest person there. Number two, I was the only person that wasn't disparaging NASA on that call. And I was the only person on that call that advocated for NASA to have a goal of humans to Mars. I was kind of disappointed with that call. You sort of had the blue team and the red team both on that call, the people that would help whoever had won that election to do the transition at NASA. But they were talking NASA down. They were like, NASA can't do anything. And I repeatedly said NASA should have a goal of humans to Mars that would galvanize the agency. Then the Trump inauguration speech happened. I'm not going to take credit for him announcing humans to Mars, but I just, it was out there, and they were talking about it. The one other thing that they did commit to us in that meeting was that NASA would have an ombudsman for nonprofits. I'm still waiting for them to do that, but I think that would be a good thing to have at NASA for us to have an ombudsman that could advocate for, what we advocate for at the Mars Society, but some of the other nonprofits as well, having a voice within NASA. So we also, at the time, Jared Isaacman was going to be the NASA nominee, and we were very pro Jared Isaacman. We are very pro Jared Isaacman. We think he would have been a fantastic administrator. We had helped Jim Bridenstine get confirmed. We had a small role in that 8 years ago or so. And so we offered to do that again. They didn't need us. They said he's going to sail right through. But then I guess the word on the street is they pulled his nomination as a retaliation to Elon and Trump's feud. That's why Jared Isaacman isn't the NASA administrator today. And then when we got wind of all of the NASA potential budget cuts to the science budget back in April, like March, April, we got wind of that. And Robert and I immediately rallied with the Planetary Society to start fighting this. And many of you may remember, we at the Mars Society have a history of mobilizing when NASA missions are in danger, such as the Curiosity rover. Back in 2008, there was danger, and Robert just mentioned the name Sean O'Keefe. There was danger of that mission getting gutted, canceled, and so we rallied back then Robert spoke in DC at a press conference at the National Press Club with others, and we saved the Curiosity mission. And so you know, we're not new at this, although we have new people now since 2008. But we immediately started working with the Planetary Society, and I think they've done a fantastic job this year of organizing. They just did a day of action in Washington, D.C. this week. And as a matter of fact, I have a little video from that. We had a member of our DC chapter at that press conference. And here's a little, I hope this sound works. Here's a little news package that wraps up with how that event went. I think we're having AV issues today. I don't know if we're going to be able to see this one. Let me see if I can. If I can work a little magic here. If not, I'll just talk over it. Yeah, okay. So, yeah, so this event, unfortunately, the sound's not working. This event happened on, I believe, the Capitol steps on Monday, and it was well attended by the press. Bill Nye there is the head of the Planetary Society. This was a local TV news package in the DC area that wrapped it up, and it basically just what Robert said, advocating for NASA science budget, talking about the draconian nature of these cuts and how they would affect all of science, not just NASA, how we need NASA's science budget to settle Mars, to go back to the moon and to Mars. They're tightly interlinked. And so, you know, so I'm pretty proud that we were able to be part of that event. And now we've got several folks across the Mars Society mobilizing to help us with further advocacy, talking, and we need your help as well. If you're interested in joining us and helping with our political action with this, we'd love your help. We need help on it. We are a nonprofit. We're a 501c3 in the US, which means that we cannot advocate directly for a candidate, and we can't spend a significant quote unquote amount of money on political activity, but it doesn't prohibit us from advocating for an issue like this. And like, as I said, we have a track record of that. And so we need your help. We're growing our chapters to work across the US, to reach out to Congress people, to reach out to the general public, to educate people on this issue and hopefully turn things around. So, so that's going to be our goal moving forward. And like I said, we'd love your help on that. Okay, I'll also give a couple little updates on the Mars Society this year. So we have 3 analog research stations now that we operate. We have the Mars Desert Research Station in Utah, which are in our 26th field season now. Over 315 crews there, over 2,000 analog astronauts, 4 of which have become real astronauts. So if you go through our MDRS program, there's a 1 in 500 chance that you can become an astronaut. We also, and that is, we are part of a global community of analog stations. There's analog stations all around the world. There is a project called the World's Biggest Analog that we're part of, that next week we'll be having crews in about 30 different stations at the same time with some coordinated research. And there's a mission control in Austria that's going to coordinate the experiments that folks are doing. But we have an all-star crew at our station in Utah that's starting next week as part of this World's Biggest Analog event. And we're really looking forward to seeing how that goes. There's definitely going to be some press on it. There's one of our crew members is doing some work with Nat Geo, for example. And so we're really excited about that. Flashline, our station in the Arctic in Canada, we have had our 3rd field season for the last 3 years. We've had a field season after having a 7-year hiatus. And I can tell you that station is in the best shape it's ever been. We've sent an excellent crew of engineers this past June, July to refit it. And then we did 2 science crews after that. So we actually did 3 crews this field season in Flashline. That's a record for us, about 18 people total. And every year we do that mission. It's in July. And you know, it's basically an uninhabited island the size of Ireland in the Arctic Circle called Devon Island. And we're right next to a perfectly preserved impact crater called Houghton Crater. NASA has been going up there for a very long time just to do studies, and they have a base camp nearby, but we built that station in 2001. And like I said, 3 years in a row now we've sent a field season, and we hope to keep that going. And our new station is in India. It's in Kashmir. It's called HOPE, Himalayan Outpost for Planetary Exploration. And this is a new project with the Mars Society of Australia and a company called Protoplanet. And so we are one of the founding partners of that project, and to the tune, like we helped fund it as well. We're going to help select the crews. We'll have 3 to 4 crews per year at that station. It's at a high altitude lake, about, I think, 14,000 feet up in the Himalayas. Very scientifically interesting salt lake. And so I've talked to folks about potentially being on a crew there, and everyone's in the scientific community I've talked to is really excited about that. And so we're really, you know, that's a 3rd station now that we have available. And because we have these 3 stations, we can sort of develop crew members through our mission support teams, where you can become a mission support volunteer, learn kind of how we do analog astronauts and analog research activities, and then become a crew member. And so that's an opportunity for everybody who's interested in becoming an analog astronaut and staying at one of our stations to help out with these projects. We also at the Mars Society have done an summer engineering competition for high schoolers for the last 4 years now. This year we had over 1,000 students on that competition, over 16 teams. And some of those teams, a couple of them will be presenting tomorrow at the end of the Mars Against Hunger track that we have at this conference. We're also gearing up to do our, I think, it's about 15th University Rover Challenge next year, next June. And that's always been a very successful program. We usually have about 36 teams that come out to Utah with their Mars rovers that they've developed at the universities and compete with them. There's several challenges they do. So we'll be doing that one again this year. And then finally, the Mars Technology Institute. So we started the Mars Technology Institute about 2 years ago. We did a crowdfunding campaign that raised about $130,000 to get that project going. And we are developing an incubator accelerator program for companies that can help us develop the technologies that will help us settle Mars, but that have direct commercial applications today here on Earth. And some of the companies that we are working with that we're helping to get started are going to be speaking at the conference and unveiling what they're doing. And so that's very exciting. We think that that's something that moving forward will really help throw gasoline on the Mars movement as well. Let's see. So that's in a nutshell, that's what we've been up to for the past year. Like I said, political activities are top of mind in this climate. We want to make sure that we advocate well for the Mars Society, and we'd love to get your help on that. And with that, I'll take some questions. Go ahead.
I was just wondering, there's a project which was started in the Biden administration and it got rebranded under Trump. It's a $500 billion project with Japan and the US. It's called Stargate, and we want to release our general intelligence for life support. You know, and as well as LA, we just went through a big fire. So this would help rebuild LA. Would you guys be interested in supporting that? I'm working with House Representative Judy Chu to get authorization. I'm out of South Pasadena, as well as LA Board of Supervisors, Catherine Barger, as well as Mayor Braun from South Pasadena to do the pilot.
Yeah, sure. I'd love to talk with you about that
Thanks.
project. Yeah. Any other questions? Microphone's coming around to you, Bill.
So James, I think it's safe for me to say that anyone on an analog mission wants to be prepared not just to perform the objectives of the mission, but also to be prepared to go to Mars itself. So my question is, what are we doing to assure the preparedness of human beings in those missions to go to Mars, you know, from the health standpoint, emotional standpoint? I think we got the emotional standpoint and the spiritual standpoint under control since we have a wonderful objective. But how are we doing with getting people ready to go to Mars and from the health standpoint?
No, that's a great question, William. The human factors challenges of a Mars mission are precisely what we study at our stations. Many of the activities that the crews do during their 2 weeks are to acclimate them to that mindset of being on another planet, being isolated. And I can tell you, I've had several missions at MDRS. You kind of lose the fact that you're simulating Mars. It feels like you're on Mars. It feels like you're with, 6 or 7 close colleagues with your lives in each other's hands. You're in the middle of the Utah desert, or you're in the middle of the Devon Island, Arctic wasteland, and you're basically counting on each other. I could tell you, even people that work well together, you put them in a harsh environment like that, and sometimes the claws come out, but you work through it. You work through it with having a culture of safety. You have a culture of communication, making sure that people are advocating for what they need, making sure that everyone's healthy. Like, one of the key roles that we have for each crew is a health and safety officer, to make sure that everyone's, no one's dehydrated, for example. Everyone's getting enough rest. And so things like that are, may seem minor, but they really balloon and amplify problems when someone's not feeling at their best. And so, there's a lot of studies that we've been part of. There's a lot of experiments for psychological and other factors that are human factors that we definitely want to promote and do more of. And yeah, that's exactly what we're trying to do with these programs, is get people ready. We don't have the hardware, we don't have the actual spacesuits and rockets and vehicles we're going to drive around on Mars yet. Those are coming, but we can practice with what we do have. And the MDRS and flashline environments are ideal laboratories for that.
I'd like to give a quick plug to my talk this afternoon at 3:30, if I could. Jim Green, the recent NASA chief scientist, attended our health track at the NSS ISDC in June, and after he saw what we had to explain and report, he said we feel confident we have the issue of space ionizing radiation as a cause of cancer under control for our expedition class missions. And so I'll explain why he came to that conclusion this afternoon at 3:30. And by the way, you can call me Mr. Bill, your Martian man of clay.
Thank you, Mr. Bill. Any other questions?
James, thanks for the great information. I wanted to just kind of touch back on the political support from chapters. If there was, like, what would be the top 2 things you would look for members to do, both chapters? Like, if there's one thing that they should focus on for chapters, and then also for at-large members who may not be tied to one of the more active chapters, and they're just not able to engage there. If they're just kind of an at-large member, how can they contribute?
I think anyone that lives in the United States right now, it is very easy to make a phone call to your local congressperson. You can call their DC office or their local office. You will usually either get the voicemail or you'll get an aide. Tell them where you live, tell them you're in their district, and tell them I'm calling on behalf of the science budget for NASA. You know, Mr. or Mrs. So-and-so should advocate for funding for NASA. The folks that are on the congressional committees for space would be a high value target for chapters and members. You don't have to live in their district though to call them. And these calls are meaningful. Like the political opinions are measured by constituent calls and these types of outreaches. So by doing one phone call, you may be representing 1,000 people in their calculus, right? So, and it's very easy to do. It doesn't take a lot of time. You just have to get over the mental hump of doing that. So that would be number one. Just call your congressperson, call your senator, call your US representative, and just get on their radar about this. The second thing you can do is try to meet with them in person. Try to go to their office, either in DC or their local office, and try to get a meeting and bring the chapter with you, or organize a small group to come with you and try to get that meeting and try to talk to them a little bit more long form about this. So those would be the two things. You could also write a letter, you could send a fax, you could send an email, but I think phone calls are more impactful, and meetings obviously the most impactful. Thank you for the question.
To follow up on that, there's an election coming up on November 4th for California. So Judy Chu's hosting something up in Pasadena. I don't know if you're from Pasadena, but I was going to go there and meet up with her. You know, they do public events to meet up with the citizens and find out what they're looking for. And it's for
That would
Stargate.
be wonderful. And I'll also mention, also in response to the last question, we will give everyone some talking points that they can use, and we have some of those already, but we'll put some new ones out that you could bring into meetings like that. So thank you. Yes, that would be awesome.
Hello, James.
Hello.
I have a question regarding to what extent do you think consistent underfunding to NASA's space program will postpone human exploration on Mars?
It's already done that. We should be on Mars. We should be back to the moon. I mean, if NASA had kept the level of funding they had during Apollo, we would be probably going to Alpha Centauri right now, right? So it's hugely impactful, and the human space flight side also has been drastically underfunded for humans to Mars. I mean, I remember in the 90s there was a taboo of people to work on humans to Mars at NASA, and that's how we got started. The Mars Underground, which was the precursor to the Mars Society, got started because of that. So yeah, it's a huge issue, and that's part of saving, but we have to also save the science side. We can't just shift the money from the science side to a bunch of government contracts for SpaceX and Blue Origin and folks like that. We need both. You know, these things go together. So we have to advocate for funding across NASA.
Thank you.
Right in front of you there. There you go.
So does America have the money because they need to sustain the army and all of the other in the military and store enough companies to make the rockets and stuff?
The funny thing about putting money into space is that it is an investment. It is the best kind of investment to make. It's pure R&D. You're creating new breakthroughs, new discoveries in space. And so to answer your question, yes, the United States has the money. We could do all those things. You know, and NASA is a small fraction of the total spending of the government. And it's a small fraction of the military spending. You know, if it was up to me, I would just say, let's outlaw war and redirect all the militaries of the world to just shift over to space, and we'd be fine. Maybe someday that'll happen, but for now, you know, we have our job to do. Over here. I think I'll have to take one more. We're going to bring on our next speaker after me. I'd love to hear what he has to say.
Thank you very much. My name is Paul. I'm very much interested in how this Mars Society can go more international. You talk about chapters here in the United States a lot, but I would like to see more an excursion out into international, with Dr. Zubrin being involved directly, going in those conferences and really help promote the idea of international effort to get to Mars, because it's a very important mission to be done.
Yes.
And I'd like to hear your words on that.
Absolutely. I haven't talked about it a lot this morning because I've been focused on the US in my talk, but we have a very robust set of international chapters. I mentioned we're in about 50 countries. So we have, for example, a European Mars Society conference happening in November. November 29th in Paris is and that's actually the first European Mars Society conference since COVID, since 2019. So we're really excited about that. We have in India, we have a chapter called the Mars Society of South Asia that does a rover competition like the one we do in Utah. We have about 36 teams, about 400 people come to that. They have over 1,000. Ours is about 3 days. Theirs is over a week. You know, so there's a very robust set of folks in India that work on humans to Mars. There's folks, we have chapters across Europe. We have very robust chapters in South America, Peru, Brazil. There's a Habitat Marte as part of our Mars analog community. I don't know if Julio's here, but he comes to our conference a lot. He's from Brazil. And so, yeah, there's a very robust international community already. And we want to help. They're all independent of us. Like the Mars Society US, we sort of try to set the agenda, but all these other chapters internationally, do it their way, which is totally fine. But we definitely want to grow those chapters and develop of them. So, but yeah, it's absolutely very important. And just like we do political activity in the US, we encourage our international chapters to do similar outreach to government and industry for humans to Mars. So we actually have a 25 plus year history of that already. Okay, last question, and then I have to get off the stage.
What is the Mars Society's position regarding advocating for the Mars sample return mission and any ongoing programs to get that back on track?
That's a great question. We had at our conference last year in Seattle, we had all of the NASA senior officials for Mars sample return. And we asked them, what's your plan? Come present your plan for Mars sample return. And they were in the middle of an exercise of looking at the industry plans that had been submitted to them. So they didn't really have an answer for us. And I believe they kind of still don't. They're still it's a little bit in limbo. There's no funding for that mission. Robert mentioned yesterday that instead of doing one big flagship Mars sample return mission, it would probably be better for NASA to go back to the Mars Surveyor program in the 90s, where, after Mars Pathfinder, we were going to do a mission every Mars opportunity. That was a small Discovery class mission. That would have been more effective to do over this last 20 years than having 2 flagship rover programs, and then now the Mars sample return that got canceled. Do you want to say something on this?
Yeah. In answer to your question, okay, there isn't a Mars Society position on this issue. Okay. There are different people in the Mars Society have their views on this issue, and we are kind of a forum for that. I have my own view, which, as Jim just said, is that I think that having a multitude of small and medium missions would be a more effective program and much less risky than the Mars sample return. Because if you had, instead of one $10 billion mission that counts on 3 different spacecraft all working and working together, you have, for $10 billion, you have 20 missions averaging cost $500 million each. So they don't have to be all small. Some can be medium and even a few Curiosity size. But averaging to $500 million each, you've got 20 missions and you can do all sorts of things. You can do life detection experiments. We haven't done a life detection experiment on Mars since 1976. Okay, that's a half century ago. Okay, and NASA says the reason for its Mars program is the search for life. Okay, except they're not searching for life. Okay, so I think if your reason for your program is to search for life, at least some of it should be searching for life. Okay, so we could do that, and we could also have drillers, and yes, helicopters and balloons and static landers and seismic networks and orbiters with ground penetrating radar, and maybe airplanes with ground penetrating radar to look for underground aquifers. I mean, there's so many things you could do, and with a multitude of rovers and helicopters and stuff, each one of them carrying maybe 5 instruments. So now you have 100 different scientific teams from around the world with their own instrument on some rover or helicopter or static lander or orbiter or something. It's a much richer program. And gee, if 3 out of this 20 missions fail, 17 have still succeeded, and you have a successful program. Instead, with a Mars sample return with 3 spacecraft, the ascent vehicle, the rover that's rendezvousing with it, and the orbiter, you got 3 vehicles, and if one of them fails, the whole mission fails. And it's not as good. Anyway, that's my position. The Mars Society also definitely includes people who say, no, sample return's the way to go. Get that sample back to Earth, and we could have it in 100 different labs on Earth, all analyzing it with all kinds of fancy instruments that you can't send to Mars. Okay, that's a different point of view. But the one, I guess there is a Mars Society position, is that there should be a Mars exploration program. Okay, and that's where we are now. Okay.
Thank you, Robert. All right, our next speaker is Hoppy Price. He is currently the chief engineer for NASA's Robotic Mars Exploration Program. So he's going to tell us exactly what's going on with that. And he started at JPL, I believe, on April Fool's Day, 1978, I read. Yeah, 78. Served as the configuration engineer on the Cassini orbiter, and also was the architect of JPL's architecture for humans to Mars. So we'd love to hear what you have to say. Hoppy, come on up to the stage.
Okay, looks like we're live here. And here's the stuff. Okay, so this is one of my favorite images here. It's from the Curiosity rover, which has been climbing up Mount Sharp in the center of Gale Crater on Mars. And so in this image, it's in the middle of a channel, which billions of years ago had water running through it. And you can see off into the distance Gale Crater. And Curiosity has been operating for 13 years, thanks to, let's see, does the cursor show here? Can you see the cursor? No. Okay. Because we have an RTG power supply here, you can see the radiator fins. That's enabled us to operate for 13 years on Mars. It's still doing great science, making fantastic discoveries. We currently have 5 U.S. missions operating at Mars. 3 orbiters and 2 rovers, and then there are 4 non-U.S. missions. So Mars Odyssey, named after 2001: A Space Odyssey, was launched in 2001, and it has a thermal imager, which is really essential for doing some of our landing sites investigations for humans to Mars to do rock abundances. MRO has the high-rise imager, which can image things on Mars down to 30-centimeter resolution. That's also essential for validating landing sites. And in fact, MRO has done some images for SpaceX to look at one of their landing sites at Arcadia on Mars. And then, of course, Curiosity is doing great stuff. We have the MAVEN mission, which is managed by Goddard Space Flight Center. And that's looking at how Mars's atmosphere evolved and why Mars lost its atmosphere. We're understanding how the solar wind blows the atmosphere away. It only has 1/3 the gravity of Earth. So, terraforming Mars in the future is always going to be a challenge because of the solar wind, tending to blow away the atmosphere. So just like John Carter on Mars, they had an oxygen plant there on Barsoom to keep regenerating the oxygen. We might need something like that. And then Mars 2020, the Perseverance rover with the Ingenuity helicopter has made some amazing discoveries and has a number of samples that we would like to bring back to Earth, which may have compelling evidence as to the possibility of there having been past microbial life on Mars. And then the non-US missions, the Mars Express has been there since 2003, still going strong, has a great radar experiment. The Trace Gas Orbiter is a very robust orbiter, and it's really the workhorse now for relay operations, getting data back from our rovers, but of course Odyssey and MRO and MAVEN are also very important for the relay activities. They're all very important. United Arab Emirates has the Hope orbiter, which is doing some unique measurements. And then China has an orbiter, which actually has a pretty good imager, not quite as good as MRO, but it's pretty good. It does very high resolution images of the surface. So looking at what the Perseverance rover has done, we can kind of look at the history of what it did. It landed here in Jezero crater and did a little side sweep over here, looking at some interesting things, took a number of samples and kind of went around this rough area here, but the Ingenuity helicopter could actually fly over the rough terrain and do some scouting ahead, so that was very useful. And then this is the Three Forks area where there's 3 different river forks that came together here. We took a number of samples there. The reason is we wanted to leave a cache of samples here. There's 10 sample tubes that we deposited here in the event that the Perseverance rover becomes disabled in the future, is not able to return samples. We do have a cache of samples that would be valuable for return. And then the Perseverance rover went up the crater wall over some of this this fan of debris that came from river channels. Went up around this crater here, went up towards the crater rim, and Ingenuity had 72 flights. It ended up kind of having a bad landing on a sand dune where one of the propellers kind of dug into a sand dune, but the actual vehicle still operates, and we could still get radio messages back and forth. It can still charge the batteries and send radio signals, but it can't fly anymore. And then we ended up here at this area where we took the Chayava Fall sample. That was in a riverbed that had some ancient mudstones there, and I'll talk a little bit more about that later. And now Perseverance continues around on the rim of the crater, gathering some really interesting samples that we hope will be able to return to Earth. So Mars sample returns has been a topic of discussion. We continue to collect scientifically valuable core samples for potential return to Earth. And the Chayava Fall sample is particularly interesting. It may have compelling evidence of ancient microbial life on Mars. So 3.5 billion years ago, the conditions on Mars were very similar to the conditions on Earth. There was an atmosphere that could support liquid fresh water on the surface. We know that on Earth, once the conditions became habitable for life, microbial life arose very quickly. And so on Mars, we wonder, did the same thing happen on Mars? Similar conditions. So addressing the cost of Mars sample return, we have been looking at ways to implement a cheaper mission. And the key is the MAV. The MAV is very heavy. And so that drives the mass of the whole system and therefore the cost of the whole system. So We are developing a new MAV design concept that's smaller, and we're looking at a way to deliver a smaller lander using our proven sky crane approach, where we can just drop it down on the surface like we did Curiosity and Perseverance. And so that would also be a cost savings, because now we're just rebuilding the system that we already have. And of course, industry is looking at alternatives for a large lander to bring a MAV to Mars and be able to bring the samples back. And so NASA still has not made a decision on Mars sample return. The funding for that is still in question, but we still do have people working Mars sample return at JPL and at other NASA centers. And ESA continues to develop the Earth Return Orbiter to bring the samples from Mars orbit back to Earth. They're fully funded, and they do plan on building that orbiter and launching it. So I just want to, there's a little yellow box down here, and I need to make sure I make it clear that this is a concept. Mars sample return is not a program that's been given the go-ahead, and so I'm giving this information just to let you know where we stand right now. So Mars Exploration Program has released a future plan that incorporates inputs from across the planetary science community, and we do have a big science community, international one. There's a link there where you can get this future plan. It's a fairly long document. So looking forward, we plan to implement a sustainable portfolio of missions that can address our critical and aging infrastructure. You know, the Odyssey and MRO are getting kind of old, and you know, we could lose our high resolution imaging capabilities, so we'd like to have a replacement for that, and also to replace our relay orbiters and many other capabilities that we have for science instruments. And we want to take advantage of the expanding commercial space business environment. I'll talk a little bit more about that later. And of course, to help prepare for human exploration of Mars. I'm a big fan of humans to Mars, and I think sending humans there would give us the best chance of finding compelling evidence for past and possibly even present life on Mars. So looking at some of the images there, there's on the upper right, there's the Mars Science Helicopter. That's sort of where we'd like to go after the Ingenuity helicopter and be able to do some really unique science with a helicopter getting to terrain that we can't get to anywhere else. And to access subsurface ice, we need to develop deep drilling. So we definitely are pursuing technologies to do that. So some of the future Mars planned science themes are exploring the potential for Martian life and looking for past and present life. So the upper right sample is the Chayava Falls sample. That's mudstone, and you can see sort of a zoom in close up of this leopard spot on there. So when we see rocks like this on Earth, usually this type of rock, which looks just like this, with those leopard spots, is evidence of past microbial life. And so that little ring of minerals there is what results of microbes having eaten and reacted with some of the minerals in the rock. So the Chayava Falls sample, that doesn't mean that it is evidence of past life, but it's compelling. And so there are other ways that you can get a mineral formation like this. They generally involve having high heating of the minerals to get these chemical reactions to happen. We actually don't see evidence of heating in these samples, but the only way that we'll know for sure is to actually bring the sample back to Earth. So to me, that's a very compelling evidence to bring back those samples. We want to support human exploration of Mars to collect science that's synergistic with objectives for human exploration. That's looking for evidence of subsurface ice that could support resource utilization, and also the weather, being able to characterize the weather for entry, descent, and landing, and then to do experiments for ISRU, in situ resource utilization. And for the science part, we want to continue to reveal Mars as a dynamic planetary system. There's sort of this cutaway of what Mars might look like underneath the surface. We know that there is a lot of subsurface ice, and every now and then we see some evidence that there might be subsurface liquid water, and that's something we want to continue to explore. And what we learned about Mars helps us learn about not only the Earth, but also as we study exoplanets around other stars, each of these planets in our solar system is a laboratory for what we might expect to see in other star systems. And so when we look at what the Mars atmosphere is like, what the Venus atmosphere is like, we hope to use spectrometer measurements from exoplanets to try to characterize planets around other star systems, and this all helps us with that. So looking at future Mars opportunities, what we want to do in our future plan is to establish a regular cadence of science-driven missions, and that runs the gambit from low-cost missions, which is what Robert was talking about, doing a lot of low-cost missions, and we are looking at options for that. Medium-class missions, and also missions of opportunity that might be competed payloads or ride shares with other missions that are going to Mars, maybe even commercial missions. And some of those could even be possibly flagship type missions. So the low-cost missions are in the $100 to $300 million range. Medium-class missions would be a little bit more. And then there's the missions of opportunity. So you can read more about those in the future plan. So some of the things we'd like to do are monitoring and predicting Mars weather. We know that there is methane that seeps out onto the surface of Mars. The Curiosity rover has a methane detector, and we occasionally see methane. It tends to be seasonal in Gale Crater, and so it's possible that the methane could be from subsurface microbes generating methane, or it could be for some kind of subsurface geothermal activity. And so we'd like to learn more about that. We'd like to be able to determine the location and nature of those methane seeps. We want to do ice mapping from orbit. There's been an international study for the International Mars Ice Mapping Mission, and right now that's not been approved, but it's still being studied. A lot of work has gone into that to try to characterize where the ice is on Mars. And then in the decadal survey from the National Academy of Sciences, they make their decadal recommendations, and one of the higher priority missions is the Mars Life Explorer, MLE. We also call that the Search for Life experiment. And so that would be to go to a region like Arcadia that we know has subsurface ice with only a very not very deep layer of topsoil on top, maybe a meter or less of topsoil in some locations. So we'd like to drill down into the ice and actually have a life detection experiment, as Robert was pulling for, to see if there might be a microbial life that exists in the ice at a depth where they would be shielded from the galactic cosmic radiation that we see on the surface of Mars. And of course, supporting human exploration. So we have some imaging places we'd like to go. This is an image of an ice scarp that comes from MRO. And so this is a glacier of ice. It's about 100 meters deep, and it's mostly pure fresh water. And there's so this is a vertical cliff. It's hard to tell from the image. And then this is a flat surface on top. And there's only a very minimal amount of regolith on top of this ice, but that kind of protects it thermally. And so this has been here for billions of years, and it's just waiting there. There are a number of sinkholes on Mars into lava tubes, and we'd like to fly a helicopter or other type of rover into those tubes. There's an image of a concept that we've developed a lot of prototypes for a two-wheel cave explorer on a tether. We also have a cliff explorer that we've developed. It's like a spider, and it has insect-type arms that can stick to the walls and climb up and down cliffs or go into caves. So these are all concepts that we've studied, and we would like to potentially do missions using those types of vehicles in the future. There are a number of companies that have expressed interest in providing commercial service carriers for delivering multiple spacecraft to Mars in different ranges of sizes, and that could include flyby missions, orbital missions, and/or lander missions. So NASA did fund studies last year for a number of commercial concepts, and there is a NASA website where you can see the result of that, and that's where I took these images from. So Firefly has a concept for a commercial Mars mission. So does Impulse Space, Lockheed Martin, Robotic, Blue Origin has their Blue Ring system, which can be adapted to send multiple payloads to Mars. And then ULA has a concept using their upper stage with a sunshade. That's actually a LOX hydrogen system to carry a number of payloads to Mars. And we've been looking at a low-cost rough lander concept at JPL, and so this low-cost EDL concept would avoid the airbags, the terminal descent rockets, and expensive hardware and software. The landing shot's about 1,000 Gs, but we have instruments and we have electronics that can survive that. In fact, over here, there's a drop. We have a drop test tower at JPL where we can actually simulate the landing velocity, which is anywhere between 50 to 100 miles an hour when it hits the surface. And we have sort of this mechanical shock absorbing system that works pretty well. And so we did a simulated landing on Mars with this type of a system. And in here, we actually had an Android cell phone, just like my Android cell phone. And so after we did the drop test, it had 1,000 Gs. We took out the cell phone. It worked just fine, which is really good because we didn't have to make a claim on the insurance we had for dropping your phone, you know, to replace the phone. It worked out fine. So you can see in this EDL diagram here, this is the way we typically do EDL at Mars. We have aerodynamic deceleration. We do a supersonic drogue chute to slow us down even more, enough to where we can deploy a big main chute without shredding it to pieces. That's why we have to have the drogue chute before we take out the main chute. And in this concept, we just go down the parachute all the way to the surface. And so that's where we get like a 50 mile an hour to 100 mile an hour impact. And we're pretty confident after our testing that we can build systems that can survive that and maybe even have small rovers and do different kinds of science experiments on Mars and deliver these payloads in a much cheaper manner than we have in the past. So let's see, I'm going to show a video here, if I can get that going. So this is, the Mars Science Helicopter chopper concept. So this is a 6-blade system, you know, going through a canyon like Mariner Valley, Valles Marineris, being able to look at the layers on the side, being able to go into rough terrain and fly around. We've done some development tests with this type of a system. I think there's another scene here. Yeah, and so this is another scene of the chopper just flying over rough terrain, getting to areas that we couldn't get to with typical type of rovers and examine some interesting things. So, and then let's see, oops. Okay, and then there's another concept that we've worked with AeroVironment. AeroVironment was a partner for the Ingenuity helicopter. And so AeroVironment did this video here of something called Skyfall. And so this has some similarities actually to Dragonfly on Titan in that we come in on a parachute and then we drop the heat shield and we actually deploy the helicopters midair rather than landing them. And this is what Dragonfly plans on doing on Titan. But these are sort of advanced versions of the Ingenuity helicopter that could fly off and go in different directions. And of course, this saves a lot of money because we don't actually have to have a lander that lands on the surface. We just deploy things in midair. And so these helicopters could go out in different directions and do parallel scouting of areas on Mars. And we're looking at ground penetrating radar that these things could carry to search for water, subsurface water, and also scout out human landing sites. And just to give you a perspective on how the helicopters would work, they would be solar powered. And so they would have to charge up with the sun for a whole day. And then after they charge up, they can generally operate for something like about 3 minutes, which is similar to what the Ingenuity helicopter did. But Ingenuity could fly pretty fast, and these helicopters here could also fly fast. So, you know, in 3 minutes, you can actually cover quite a bit of ground. So, some closing comments. NASA currently has a thriving Mars exploration program with orbiters and rovers that continue to provide groundbreaking science discoveries. The Mars exploration program is exploring a wide range of concepts for exciting and scientifically valuable future missions that could fit within the expected funding environment, which is a little uncertain right now, but we're all doing the best we can. And then commercial services and partnerships would be key to successful implementation and bringing down costs. And we do have funding for new technology developments. And so we are actually developing new technologies for power sources using radioisotopes other than plutonium, like americium-241. So they would be potentially cheaper and more easily available to power some of these systems. Advanced electronics and entry, descent, and landing techniques like the rough lander that we saw there. And then advanced concepts for science instruments to bring down the mass and the cost, and also to be able to do new kinds of measurements that we haven't been able to do before. And of course, paving the way for human exploration of Mars is a driving goal. And with that, I'm happy to take any questions that people have. Yeah, back there. Yeah, yeah. Oh, okay, there we go.
I'm interested in exploring a bit further the search for life and what you mentioned about methane.
Yeah.
I understand one can distinguish between biogenic and abiogenic methane based on the C12, C13 carbon isotopes. It's not easy to do. I'm wondering if there's any plan to deploy any instrument packages to Mars that would be able to distinguish whether the methane is likely of biological or geological origin. And in a larger sense, for the search for life, when I went to COSPAR in 2018, I attended the Planetary Protection Panel presentations there, and they were very clear at that point. They took a dim view of landing in the places where there's most likely to be life on Mars. They wanted to keep missions away from there and sample returns. Has anything changed in the last 7 years? I mean, can we go where life is most likely in future missions at this point, or are there still planetary protection obstacles?
So we're still adhering to those COSPAR recommendations, and we have a planetary protection officer at NASA. And so we put a lot of effort in our MLE experiment that was in the decadal survey to show that we could have a sterilized system that can drill into the ice and be able to take measurements with systems that are all sterilized so that we can be assured that we're not injecting any Earth microbes into that. And I think a good test case is actually the sample tubes that we have on the Perseverance rover. So we had a requirement on Perseverance that the sample caching area and the tubes had to have less than 1 microbe on them. And so we went through this tremendous verification program, and I think we demonstrated that the system we have on Mars right now with Perseverance, the areas that are contacting our samples don't have any microbes on them. So that way, when we bring back the samples, if we see something, we can hopefully be assured that it's not an Earth microorganism because we didn't send any there. But just to be sure, we also take these swab samples of everything in the clean rooms, and we do a genotyping of them, and we have them all in a database. So if we see something coming back from Mars, we would definitely check with our genomic inventory database to make sure it wasn't one of the critters in our clean room. And we do have all kinds of critters in the clean room that have evolved to survive only in clean rooms. Life is tenacious. But anyway, we have pretty good confidence that we'll be able to meet the planetary protection requirements in a search for life experiment.
And characterizing methane, are there any instrument packages that we might be able to deploy to Mars that are under development?
People are thinking about that. So I think the first thing is to actually find out where is the methane coming from, and that might give us some clues. But then also, as you mentioned, isotopic measurements of that would also be valuable. And also for future sample return missions, it's possible we could take samples of the methane and bring it back. For Mars sample return, we do have air samples, atmospheric samples, just for similar type purposes to look at the atmosphere on Mars that we would bring back and be able to examine a pristine sample of the atmosphere. Okay, back there.
So you mentioned that rough landing concept that you guys were working on that was able to protect an Android phone from, what was it, 1,000 Gs?
Yeah, 1,000 Gs.
Would this be something that would maybe theoretically be implemented in human missions, or would that be considered too risky?
Oh, to send humans on a rough landing like that? Well, it's interesting. There was this movie that came out that had humans going to Mars, and they had a problem, and so they had airbags, and so they bounced around in the airbags. So, yeah, I think that would probably be a little cruel to send people with a system like that. And you certainly wouldn't do the rough landing. But yeah, no, I think for landing humans on Mars, we want a nice soft landing system. Yeah.
Thank you. And just thank you again just for joining, presenting to us, and for everything that you and the teams do. Very much appreciated. Question on the data relays. Have read that DTN, disruption and delay tolerant networking, could be part of future relay architectures. Just wondering if that's part of it, and if not, what would be the threshold in terms of mission distance or complexity where that technology would be introduced?
So you've now reached outside my area of expertise, but what I can tell you about our current relay system is we have a UHF communications between our surface assets and our orbiters, and so that's how we get the data back and forth from our surface assets. And so in the near future, we plan to continue to use those UHF links because we have all kinds of systems that have been developed, and they're in a number of different international orbiters, and so we're going to probably stick with that for a while. And then to get the data back from the orbiter to Earth, we use X-band, we've used Ka-band, and in the future we'll probably use optical communication. And then also we know that SpaceX has been looking at a version of Starlink at Mars, and so again, you know, if we speculate off of what they've done with Starlink, they would probably have laser cross communication amongst their Mars orbiters, and then as far as the link to the surface assets, I think that's a decision that would be made for the future. But as we look for humans to Mars, definitely we need to have a very robust data relay system around Mars that can have continuous communication with the surface assets, the people, and also being able to send lots of data back and forth to Earth.
Could you talk a bit about some of the fundamental reasons why Mars sample return has to be such an expensive mission?
I think a lot of it has to do with the Mars ascent vehicle and how large it was. And so for us, the big challenge, that's the big lever, because, you know, you have this gear ratio. Anytime you're landing something on the moon or Mars and you're bringing something back, you know, it's the thing you're bringing back is the big lever, and how massive things are and how much they cost. And so really the key to bringing down the cost is reducing the mass of the MAV and the volume of the MAV too, because you have to fit in the volume. So that's really what we focused on, and we think that we've made progress in concepts that can do that. And one of the keys is actually using lower mass avionics. So the concept we're looking at now for the MAV uses more modern electronics, like what's in a cell phone, like what was in the Ingenuity helicopter, rather than the more massive avionics that we've had on our orbiters and rovers on Mars. Yes, Matt.
Hoppy, until looking at those advanced helicopters seems to be even more evidence that, you know, until we can start subscribing to Starlink at Mars, the importance of those relay satellites. Maven is at least middle-aged.
Yeah.
MRO, Mars Reconnaissance Orbiter, is ancient.
Yeah.
If we lose them, we're in big trouble. I mean, are there any concrete plans now to give us new relay capabilities on orbit?
Yeah. So in the big, beautiful bill, there was $700 million put in that for a future Mars telecommunication orbiter. And so we'll see where that goes. But I mean, you know, that's a chunk of change for an orbiter. You know, it might be an ion drive mission. We don't know. That would give it more robust delta V capability. It could also possibly carry other payloads and have a high resolution camera. So I think, you know, that's something to look forward to. There's something concrete happening with that telecom orbiter.
Question over here.
Have you considered, you were showing us that video of the advanced drones, and they were all working, and you could deploy multiple of them through, like, in the air. You were saying that they have to charge by the sun. Have you considered using that rough landing kind of strategy that you talked about to actually land the thing where they've been deployed from and have, like, a nuclear power source so they can charge again?
Yeah, so that's actually interesting. You know, you might have a rough lander that would land on the surface with, say, an americium-241 radioisotope power source as a charging station. But I would still think you might want to deploy your helicopters midair, because the helicopters wouldn't survive 1,000 Gs. You know, the rotor blades and the solar cells, just some of the systems we have in there wouldn't survive. But I think that there could be something there. But we know with the Ingenuity helicopter that, you know, we would be able to land those helicopters, and every day they would get enough sunlight to charge them, unless we had a big dust storm season in which case all bets are off. But in the case of the dust storm season, that's when it would be great to have a nuclear power supply to plug in and recharge the helicopter. So that's a good idea.
Thought is that you were talking about they have like a very short kind of time to fly after that.
They do. So when we release them in the air, they have probably about 3 minutes or so to fly and then go land somewhere, and then they'll charge the batteries. So in another day, they'll be ready to fly off again. Yeah.
Thank you. Thank you
All
so
right.
much.
Sure.
Okay, folks, we're gonna now take a short break, about a 10-minute break, and we'll pick up with our next speaker at 10:50.
Yeah. I know of him. No.
Student work?
Yeah. I'm familiar with the concept. And when I had
Yeah.
tried to use
Yeah, it's up to you guys. Whatever you want to put on. It's on the schedule. If you look on the website, it's one of these rooms in the hallway. I think it's 2 of us.
Right.
Yes. Yes. Yeah, Edwin, yeah, you have your slides here. I'm just gonna load them up.
flying to victory. And this is
Oh, wow, okay.
but so now we set up Pegasus. We've actually flown over. And then I set up a branch in the US and we just won an Air Force contract how it might fit into this. But she's lander that looks down. It's like a parachute. I'll just ask you.
I haven't seen that.
So anyway.
Oh, yeah. Okay, yeah, sounds good. Yeah, and Rob Manning's going to be here tomorrow, and if you talk, also talk to Rob. No, Rob's not retired. No. Chief Engineer Emeritus, and he just does various odds and ends, but he's still working at JPL.
I see. Okay, then I will talk to him.
Hi. Okay.
Just
Yeah. Yeah. So the atmosphere of Mars is about equivalent to the atmosphere on Earth at 100,000 feet. So our Mars helicopters, they can fly at 100,000 feet on Earth.
I don't think we have.
Yeah. There's big rotor blades, so they rotate very fast. Oh, sure, yeah.
Of which the most active is that's Mars as a research. It's in the desert, in the geological area. We actually, one of our students on EVA, under simulated conditions, made a discovery that has led to a dinosaur.
Okay, yeah, right.
So you're welcome. It's now the largest dinosaur find. Yeah, so we do analysis.
Nice to meet you.
On Earth, what we do is, no, it's not about cost, the board of blades.
Sounds perfect.
We've done some scooping of soil, so maybe for scooping, we've gone down about
Environment, there's interesting things to do. That's the point. In other words,
Mars. That would be Olympus Mons, and gosh, that's probably something. I'm just guessing right now, like 30 kilometers high or something. It's over 20,000 feet. Yeah, Olympus Mons is the tallest mountain in the solar system that we found so far. And of course, the air at the top is very, very cold. So we wouldn't be able to land something there with the current EVL techniques. So Mars has carbon dioxide atmosphere, and the air pressure is about equivalent to its atmosphere.
So that's kind of like.
So our Mars helicopter.
Okay.
On Earth at 100,000. So that's
Well, no,
MOLA,
that's-
and I forget what it stands for, but MOLA, that's like zero sea level.
Yes, they do.
And I forget exactly how they came up with the reference, but there was a big international community. Typically, we land our land so far at below zero.
But there's a good chance that.
I know that.
Yeah, sure. All right, see you. Hi. Oh, yeah, thanks.
Yeah,
we can speak. Oh, yeah. Yeah.
Good drop off space.
In the last few months, there are people.
Yeah.
No, things haven't changed in the last few months. We're just waiting for a funding picture to settle out and to see what our budget is.
Oh, well, never late for that.
If it's not disastrous, we will proceed with what's in our future plan. And so that's available online and the Mars future
Yes.
plan.
I don't
So
know where
I
we
can
live.
find soliciting commercial partners, commercial providers.
Yeah, because we didn't throw out the idea.
Sure, yeah. Those are the kind of things we've done in the past. Yeah.
Okay. May I ask a question?
Sure, yeah.
Thank you. Yeah, I'm working.
Okay, yeah. So well, Ed's a good contact. Yeah, probably better contact.
Yes,
than
we
me.
can, but I do want to show you.
Yeah. Okay, great.
Well, thank you, sir.
Yeah,
And
nice meeting you.
fantastic presentation.
Okay, great. Thank you.
Thank you.
All right. Yeah. Hi. Hi, Rick.
But,
Oh, okay.
This is 41.
Mostly, oh, yeah.
I have not personally seen a link to the Mars Society.
Yeah, so I'm not an expert on how MOXIE works. That's a mic experiment.
Like that.
There's a lot of information online you can get, but basically there are these little plates that are in here that are very carefully made and they're
Yes.
close together. And electricity, high voltage electricity across these plates, and it breaks down the carbon dioxide into carbon and oxygen. And we store the oxygen.
My question is.
Yeah, okay, good. Excellent. Well, yeah.
In
He's always asked great questions.
Yeah, carbon dioxide is a little bit of.
Yeah, like I was like.
Oh, I obviously use an experimental carbon dioxide on Earth. I don't know, I kind of don't think so. Yeah. Yeah, right. And so what we do from Oxy is we actually pressurize the atmosphere, get higher pressure carbon dioxide, and then feed that into the instrument to do the electrical breakdown into carbon and oxygen. So on Earth, I mean, most of what you're getting is nitrogen and then oxygen and a teeny bit of carbon dioxide. So I don't know if you can.
Is that very interesting, especially now, like, cheaper, the better, the smarter.
What's your name?
Melody.
Oh, yeah, lower pressure, it's like 1%.
What national?
Oh, yeah. So it takes a lot of energy to extract oxygen from carbon dioxide atmosphere. Hi. Oh, okay. I'm glad you got permission to come here.
No, I came on.
Oh, you did? Okay. Yeah, I was wondering because it was so hard.
It's so nice to see you. For everyone in space.
It's always possible.
Or anything else.
Yeah, sorry, we're gonna miss you.
I do everyone in the afternoon because you're clashing with Nina and I have.
Yeah, you have the same time.
Yeah. Now you can fill us in anyway.
How was last year? I saw.
So
Yeah, it was kind of crazy. But we made it work. It was in Seattle, my hometown.
I know you were saying, I've never been to Seattle so many times in the airport. I saw so many because we are May, our youngest one, you mentioned, she had birthday. And it was like kind of the one she said. That's why.
Hopefully we'll have it there.
Yeah, I so wish to see Seattle.
Great place.
Yeah.
Sure,
that sounds fine.
So
Okay,
high
nice
tech,
meeting you.
it's so intelligent.
So did you get the photo?
I am.
Yeah, I saw it on the.
Take all the work out of it for me.
I just had some research, my research. I completed my research this year, so I'm officially doctor.
Oh, congratulations.
Thank you so much. It was a big time, so
Sorry?
a lot.
Hello, can you?
I was just assessing ethically
I'm just gonna
silent,
catch the Zoom code real quick so I can
and,
send it out.
they don't have a very good rate.
Of course. That's always the case, right? Craig, nice to see
Fantastic
you.
job of introducing yourself. Accolades and all. That made me laugh. Good to meet you in person. I've only seen you in conference call. So, you know Jan?
Yeah, I know Jan very well.
Okay, yeah.
No.
I talk about him all the time. He's missing. Get that sucker
Yeah, we
over.
are working on this together. I had
Yeah.
a call this morning at 7 a.m. with the head of the Texas Space Commission, Mr. Norman Garza. And then one of my former employees is great friends with them. They go hunting together. So he took me through the grant awards. They distributed $127 million across 23 projects. So I literally have a follow-up meeting with them next week in Austin, Texas. We're in the same town. So
Making it happen,
this is
Craig.
gonna it will work, right? It's just a numbers game. And I am, if I walk you through past projects, I may be slow, but I'm persistent. And always drop on them. It is the tourist that beats the hair. Type of game. So stick with that guy. It will work. So I'm just very appreciative of all of the groundwork that y'all laid over the last 25 or 30 years. I feel like I'm leveraging that to increase the odds of us getting things funded. That is what's happening. So in spirit. Yep. Yeah. So
not yet.
The only difference is the shirts. Look into one of our partner shirts or a business card or whatever. So,
Did you want to have us watching?
I was thinking it would be good for us to mention what we're doing with both Impress and the timeshare rover, just as a 30-second or 2-minute PR to ask questions. Because if you look at the mission of society, we're basically developing infrastructure. Impress is a way for people to get their payloads there faster and cheaper, right? More reliable. The timeshare rover is a way for people to get their technology development efforts or their science experiments into the field faster and cheaper. So it's like, I want to be a truck driver. I don't want to build a truck, right? And so we're just like, oh, the truck's already made, the probe's already made. That's really the idea. It's a 30-second idea.
Also, we can do it, like, get the whole world working on this.
Yes.
That builds the advocacy.
That's the goal. To do that. So I can put together. I mean, I drafted just a little 30-second thing. You critique it to make sure that I'll just email it to you, and then I don't know.
Maybe like during slot tomorrow, or
yeah, whatever's most appropriate. Like that when we. What do you think is most appropriate? Just do a little 30-second.
I mean, I could mention it. At the,
that works too. You're actually very well spoken. I like talking, but you do it more right.
Actually, I can have you as a guest speaker during my talk as a 30-second.
That works too. But I think you add immediate legitimacy to it. So I'll send you the blurb. It's also taller than me, and that's one of my superpowers.
I wanted to say, like, I rarely feel like a small guy.
Yeah.
Now you are on a hill.
Then, review it for technical accuracy. I wrote it for marketing. Then you review it to ensure that it's aligned and approved by you. And if you make a note, then we share our contact information, that we can start to recruit people. I've already reached out to fire to bring them in. Help us to fund, develop, and promote these two vehicles, these two infrastructure vehicles.
Isn't it the one that's always 30 years away?
Yeah, so we need to start with this. No, I'll let you do your job. I can imagine you doing things right now. I just want to say hello. And pleasure to meet you in person. That worked out well. Maybe I'll share the blurb with you and let
Yeah.
Okay.
On them.
Should we just? Okay, let's get rolling first. Yeah. So you got the neighborhood. Okay, folks, we're gonna get rolling with the next speaker. If you can all take your seats or take your conversations outside, that would be great. If you could all take your seats or take your conversations outside, that would be great. We're going to get rolling with the next speaker. Okay, folks, our next speaker is Dr. Juliana Rinaldi-Semione. She's a professor at the University of Nottingham in the UK, and she's done some really interesting work to tie together things with Mars, and I'll let her talk all about that.
Well, hello, everybody. I am delighted to be here today for more than one reason, and I'm really enjoying the sunshine. Nottingham is in England, and it is right in the middle of the country. There are no beaches. There is hardly any sunshine at this time of year, especially, and it's night by 4:30 p.m. So I'm really delighted to be back in my home area of Southern California, and really delighted to be speaking to you in person. The last time I was able to speak with you, it was virtually because, again, Nottingham. So I wanted to just give a brief introduction to myself and highlight just a couple pertinent things about my background that I hope will come together for you as we get down the road in this talk. So my career started in anti-human trafficking work here in Southern California as a part of the Orange County Human Trafficking Task Force. I could go into details about that, but the really pertinent thing is that that's where it all started for me. And I started asking questions about human rights and justice and equity and society that we didn't have answers to. So I thought, I'm going to go into academia, I'm going to do some research, I'm going to try and answer those questions. That'll be my contribution to the anti-trafficking field. So I moved to the UK to do postgraduate work, and at the same time, I kept up my sort of on-the-ground relevance, if you will, by working with the Salvation Army in the UK, building programs to support survivors of modern slavery and human trafficking. And as I got through that sort of pragmatic work, and as I got through the academic work alongside it, I started to realize that we had a disciplinary divide that was not serving us in social justice issues. And I've had a lifelong interest in space and been a part of the Space Generation Advisory Council and organizations like that, which until my time in Nottingham was separate from my professional life. And I started to realize the way that social scientists talk about human trafficking and other social justice issues and all the evidence that points us in those directions for solutions says that it's all intertwined. It's all connected. So you can't just talk about solving a human trafficking problem. You have to understand why human trafficking exists. And then you have to figure out how to solve those root causes. And the same is true for other complex issues like poverty and a wide variety of injustices. So this sort of intersected with me, and it collided with my personal interest in space. And I started to realize, wait a minute, we are building these plans as a human race to send ourselves permanently and long-term on space exploration missions. We talk about colonizing Mars, and we're doing these crazy things technologically. It's wild to me. I remember when Starship did its first successful belly flop, and now that's like ages ago, right? Like we've just moved on to totally different crazy things. And I thought, we are going so fast, but we're not asking how we're going or how we're going to stay there. And what's going to stop us from replicating society as we have it here on Earth, on Mars, or on the moon, or anywhere else that we put ourselves. So my work now at the University of Nottingham is around impact through research and teaching, specifically looking at how we build a better world in space than the world we have here. So all of this comes together in that sort of interdisciplinary, very cross-sectoral, multi-field perspective is going to be really key. So I'm going to ask you to put as many hats on as you have and try to view this presentation through the perspectives of the various life experiences and professional focuses that you come from. This is Mars. My brother took this photo for me a few years ago when I started asking questions. I started asking, can we make Mars the first slavery-free planet? And my social science colleagues and supervisors thought that was insane. No one's going to Mars. When I talked to friends in the space sector, they were like, oh my gosh, never thought about that. Some of them said, what's human trafficking? And then, started to think about sustainability, which is something that we're going to discuss today. And so I also found this strange divide where people who are usually more siloed, at least in our imaginations, into the technology and science side, were really curious. They brought this curiosity that, surprisingly to me, the social science side didn't bring. They weren't thinking futuristically enough to be curious about it. So my brother took this picture for me because I said to him one day, what if we could just look up at Mars? What if our grandkids look up at Mars and they think to themselves, that is the first slavery-free world? And what if kids who generations from now are born on Mars only know what slavery is because they read about it in a textbook about Earth? How do we get there? So as a social scientist, this is not a yes or no question to me. And as someone with kind of very personal buy-in as a sort of career-long commitment to social justice in my background, this is a how question. It's not yes or no. So not the close-ended question that it might look like on first glance. So this is how we're going to get there. A spoiler is that we can only get there together. We can only get there by thinking in ways that aren't natural for any of us. So all of us have a natural way of thinking in a field that we sit comfortably in and a professional expertise that we bring day to day. But all of us also have to try and understand something else about a different area of humanity or space exploration. And I'm going to give you some really solid examples of that soon. This is the roadmap of how we make Mars a slavery-free planet. And we're not actually going to talk about slavery very much from here on out because, like I said, slavery does not exist in a vacuum. You've got to look at what permits it to exist, or in this case, what can prevent it from existing. So the roadmap to a sustainable Mars is adopting a robust understanding of sustainability. We're going to spend a lot of time talking about that. The second step is applying that sustainability lens to all of our work in Mars exploration. So regardless of whether you are thinking about space weather or you are thinking about Martian airbags for helicopters, or if you're thinking about nuclear power, no matter what you're thinking about, this sustainability applies to you, and I really hope I've made that case successfully by the end of this talk. Third is seeking to understand one another and to be understood. We're not going to spend a lot of time on that, but I hope it's somewhat intuitive as we go. And finally, pursuing opportunities to co-create. So if I can get you all to agree with me that sustainability is the way forward, and I'm going to give you a definition that's a bit more holistic, then I hope you'll say, great, we can't just sit here and know that together. We have to actually work together and do something about it. So I'm going to focus on these first two steps today. That's what this is about. In the break times and in the next couple of days of our conference, I hope that you'll not only speak with me, but with each other about what does this mean? How do we do whatever we're doing more sustainably? All right, what's that word mean? And how do we adopt it? Sustainability, coming from sort of a global political agenda and science agenda perspective, so thinking up at the UN level, sustainability broadly refers to the ability to maintain or support something over a long period of time. That's not a surprising definition, right? Sort of intuitive, especially when we're thinking about the sustainability of our different contributions to Mars exploration. Sustainable development is sort of a mechanism or framework by which we can arrive at sustainability. So sustainable development, very much a UN phrase, but don't let that get in your way if you've got feelings about the UN. Sustainable development is a framework that allows us to map our global goals and chart progress towards sustainability. So toward that big goal up top about being able to maintain or support something over the long term. Sustainable development is really helpful because it starts to break down what it looks like to have a sustainable society. And this has three core elements to it: environmental protection, social inclusion, and economic growth. All of those, you're probably familiar with the implication and importance of those on Earth, in your own experience even, but those are all very important in space, whether it's in Leo or whether we're all the way on Mars or beyond. So for shorthand throughout this talk, I'm going to use the word sustainability, because if I keep saying sustainable development to you, you're going to be really tired of hearing it, and you won't want to talk about it with each other after this. This is where sustainable development comes from. Our Common Future is also called the Brundtland Report, and this was published in the 80s. And it was started, it was commissioned to search out sort of a social and economic solution for environmental problems. It was very environmental focused. But what came out of it was 300 pages plus talking about how there are absolutely ways that we can protect the environment on Earth economically, we can do it responsibly, but you have to include this social component. And so it became clear to people who were looking just from an environmental side and even from a STEM side regarding some climate change action early on, there are social aspects to this that can't be ignored, because if you ignore them, you undermine your environmental goal. So those three pillars are interconnected and have been for about the last 40 years. Okay, when it comes to actually applying a sustainability lens, we're going to get focused honing a more and more specific focus here. So we've got those three pillars now. Now we've got 17 goals, which are more specific, more discrete. How do we arrive at a sustainable future? Sustainable future for humanity is what we're talking about here. So I'm bringing the Mars perspective and the space perspective to a very Earth-driven agenda that's on the screen right now. And bear with me because I'll show you how I think we pivot that into space. So I'm just going to let you pause on this for a moment. These are just the headlines of the 17 Sustainable Development Goals, which come from a global agenda called Our Common Agenda. Very creative naming mechanisms. And so I just wonder which of these you might see a connection to your work in. So maybe just remember one or two of these that you think, yeah, that might touch on what I do. Okay, so again, narrower focus. Each Sustainable Development Goal has targets underneath it. And this is where it's going to get, in a few minutes, really relevant to my interest in Mars exploration and what I think we need to do about it. So this is just an example. SDG 12 has these 4 targets underneath it. And you can see there's specific sort of more or less achievable goals, measurable goals, I should say. You could see how someone might make a plan, an organization, whether it's a public body or a nonprofit. You might make a plan to advance one of these goals and sort of have an idea of knowing whether or not you can make progress on it, right? It's got the framings, and then you contextualize it locally. So some of these can be like global per capita food waste. That's something that lots of organizations are working on at very local levels. And also you've got national government bodies working on that in different countries. So this is one of those times we have to expand the idea. This could happen really locally on the micro scale, but also there are actions happening at the top. So top down, bottom up. That's true for all the SDGs. All right, now I'm going to step back a little bit from the SDGs, and I want to talk about what they are founded on and what documents we have in common as a global community that give us some starting place when we say, right, but we're thinking about going to space. What does that actually mean? Why this is about Earth? Why space? How does it fit? The Sustainable Development Goals are based not only on that theory of sustainable development and that brief background that I gave you out of the Brundtland report, but they are based really, they're rooted really deeply in the Universal Declaration of Human Rights. So there are many articles in the Declaration of Human Rights. Freedom from slavery is one of them. Freedom from wrongful imprisonment, all kinds of things. Recently, we've got the addition of the right to a clean and healthy environment. So that's been floating around for a number of years, and it's now been formally acknowledged as a right. So this Declaration of Human Rights is sort of a post-World War II instrument that is, I think with the exception of one country, but don't quote me on that, universally signed and ratified. That talks about how we're all equal. We all deserve decent, respectful treatment, right? Now, the UN treaties on outer space, these did not inform the SDGs because, again, they're very space-focused. But that middle document there, that set of documents, is going to be what I think our pillars should be for saying, okay, let's think about time, sustainability, and human rights together alongside sort of a three-stranded rope with the UN treaties on outer space and these agreements that we've made, at least in principle, about how we're going to treat space, how we're going to treat each other when we're there, and who gets space. Once we get out there in larger and larger numbers than we've ever done before, that's not hard to do, but once we get out there in larger and larger numbers, who gets to use it and keep it, and for how long? All those questions that we're asking right at every space conference. I've already referenced our common agenda. That's where the 17 Sustainable Development Goals come from. The thesis of our common agenda is the thesis that came out of the Brundtland report, and it has stayed consistent all these years, which is that the effect of sustainability, the framework that we need to think in, is that we should be meeting our needs in this generation without costing future generations their ability to meet their needs. And I think that is hyper relevant to space. For me, that was sort of the explosive nexus point, thinking about how and why this is relevant and what we do about it when we get to Mars. Future generations, for those of us who think we're going to Mars, include people on Mars and people on Earth. This is like a multi-planetary vision here to sustain future generations' rights to meet their needs, including their needs for ambition and their need to explore. not just to survive. There need to be respected as humans, to be somehow protected from other humans and from contradictory ways of thinking. And based on these three, what I am proposing, we should base it on these three documents, which form sort of a public political culture that the globe has already, in principle, agreed to. And we're looking at space. Nobody is living up there long term yet. So how about we start at the end? Let's start where we want to be when we build human settlements, long-term human presences, ultimately societies, colonies in space and on Mars. Start at the end. Let's get rid of the need to make sustainable development goals that correct things we've done wrong. Let's get rid of the need to say, how do we fix the fact that we've harmed the environment? Right? We're already thinking about how to do that in space. What if we take the same lens and think about how do we just protect Mars from exploitation and injustice on the social side of things? Let's just start where we want to end. I'm going to reverse engineer that outcome. Okay, so this is the SDG wheel. Again, the UN is so creative with their naming conventions. It just is what it says on the tin, like one of my least favorite British phrases. So the wheel here represents all 17 Sustainable Development Goals. They all have their own color. But I think it's a really useful logo to think about how we all fit together and how all these different concerns, some of which are yours, some of which are mine, some of which we share. These 17 are just going to look different for every person in this room. If you move one wedge, the whole structure collapses. And if you just shift one slightly, we'll look in a couple of slides from now how there are very real effects on the other ones, because that interconnectedness is real. That's not a theory, that interconnectedness of the three different components for social, economic, and environmental sustainability. That is an observation, not a proposal. So if we don't tend to the future we want to have as we're building it, what we will end up doing is allow for wobbles in what our future generations inherit, both on Mars and on Earth. So this is an example of an Earth-side wobble. This is an image showing an area of Chicago, and it's an old map. It's not current anymore, but Ta-Nehisi Coates talks about reparations, slavery reparations, and he talks about injustices that are systemic. He's written a really good essay several years back that talks about redlining. Redlining, in short, is where federally funded mortgages and housing grants and community grants would basically draw red lines, because red was a code for hazardous, is the word they used. They would draw red lines around hazardous communities. Now those communities, if you look at these maps and do this research, these communities are consistently circled red or drawn bordered red, where Black and other ethnic minorities, but mainly Black communities, have established their community. So mortgages and lenders who are federally backed would basically say, we're not going to offer competitive rates. We're not even going to encourage people to buy homes in these areas. So anybody who's interested in moving into those areas was discouraged because they could not afford it, right? The banks weren't interested in taking on what they considered a liability. On the flip side, people who lived in those areas could not afford to move out of them because areas that were not redlined were worth more than they could get selling their house in a redline zone. Now, I am touching so lightly on a very serious, very long-standing problem in the American real estate sector and in the American psyche. So I want to be sensitive to that, and I want to highly recommend this essay, which is in a reference slide at the end for you to read. But one of the knock-on effects of this, decades in, so all of this started happening in the mid-20th century. Decades in from that, you've still got these communities today. You show up in them, and you can see just across the street, if you imagine that red line from this old, outdated map, that red line still metaphorically exists. And you can see it in the environment. You can see it in the social dynamics between people. You can see it in the economics, in the statistics, in the census data. So we have a potential wobble that I talked about in the 2023 convention. We've got many potential wobbles, 17 goals. It's like a variety, like take your pick. But I talked about this one, so I'm going to just recall it back right now. Decent work in economic growth is SDG 8. One of the targets under that is to end slavery around the world. But there was a report in 2022 that my colleagues and I produced that showed like real solid correlation that we then dug into to find causation using lots of computer modeling that I did not write but did help to analyze. And we found that in the push for clean and affordable energy and climate action by means of cleaner energy, there was a definite causational relationship between that and the uptick in labor, in forced labor camps in China, because that's where a huge portion of the world's polysilicon is processed, and that polysilicon is used in solar panels. So as people and industries and whole nations were creating policies and initiatives and incentives to move people onto a solar panel grid, they're having this knock-on effect over on SDG 8, causing more slavery, greater levels of exploitation. And now no one's being evil by saying, we want solar panels. Let's convert our city grid, in some cases our national grid, to solar power. But this is a really useful imagery that I will really fight the temptation to not describe every single thread of this to you because I find it fascinating. But on the left-hand side, you see the synergies. This is drawn up from data coming out of the European Commission, who have been tracking progress on the SDGs since they launched in 2015. And basically, I've got SDG 8 here running as the origin SDG on this graphic. And it shows all the synergies is a positive word in this situation. So all the synergies where when someone makes progress on SDG 8, when there's a measurable decrease in the number of slaves or the amount of exploitation in a community or in a country, it has positive effects that are measurable and most of the time causational, but oftentimes, especially on the other side, it's going to be starts with correlation, and you got to prove the causation. They have positive effects on all of these other SDGs, right? So even though if I'm early career entry job me, working on ending modern slavery and human trafficking locally, if I'm making progress on that, I'm supporting a more global effort at other things as well, just because it falls naturally that way. Now, the trade-offs, that's a negative word here. If you look at SDG 8, making progress on SDG 8 actually sets back portions of other goals. Now, these little color slices for each of the goals, if you were like on the interactive version on the computer, you'd be able to click on, let's say, SDG 11, and you could see which of the targets under 11 is being negatively affected, whereas over here on the left-hand side, there is a target under number 11 that's being positively supported. So that's why you might see the threads, the gray and the red threads going to the same SDG. It's because different targets are being affected underneath them. Okay. What do we do about this in space? What do we do about it? I have a suggestion for, I've got a sampling of a suggestion for how we start with the SDG targets and we adapt them for space. So in this case, let's look at target 8. SDG 8, target 3 is up on the screen. It's about supporting enterprises and economic growth at multiple levels in society. Okay, so what would it mean if we were to look at this for Mars, or look at it for any portion of space? What would it mean if copious instruments were development-oriented, as the target suggests? And that means environmental, social, and economic, okay? So what if copious instruments were either updated or reinterpreted to look at more than just, well, you know all the instruments, but more than just the environmental protection of heritage sites on the moon? That's an Artemis Accords principle. You've got the Outer Space Treaty looking at space arguably as the common heritage of all mankind, although some countries have taken steps that counter that. But what's it mean if we're development focused and we don't just think about it as an economic opportunity or a scientific challenge? It's a we are world building. I don't think it'll be surprising to anyone in this room to say that Mars exploration is inherently world building. We're going to build a world. That's what we're doing. If we achieve any of our goals, let's just do it sustainably. So another example of how to adapt things, and this is where I want to say, let's think really differently than we might be used to thinking at Mars conferences. Gender equality is one of the SDGs. So you can see in here, we've got, I've got my Mars starter questions because I don't think these are definitive and I don't think that they're exhaustive. I want to sort of plant them as starter ideas, and then you could say, oh, I have a better question. You can replace mine with better questions. But let's say, what does it mean for reproductive rights to be protected in light of foreseeable population concerns around resource scarcity on Mars? If part of sustainability and part of human rights is this protection of reproductive rights across genders, what does that look like on Mars, where you have concerns that you don't necessarily start with on Earth? Okay, I'm not like attached to these questions, right? These are just like, please use them as springboards for other questions. And then final example here, how do we dampen the wobble, right? It's by asking these kinds of questions. So I'm just going to sort of rapid fire them. Sustainable Development Goal 11 is around sustainable cities and communities. One of its targets is to includes increasing the resilience against disasters and developing disaster plans. We're doing that when we think about space exploration all the time. Sometimes in the short term, sometimes in the long term, depending on what the mission is. But here's a question I asked recently at a UK space weather and space environment meeting. Do we have adequate awareness of space weather risks to planned bases off Earth, including settlements and stations? Do we have an international capacity to mitigate them? That's what's required on the Earth side of things. Do we have that in space? Do we need it? If not, what do we need instead of it? What are the cascading risks of a space weather event that adversely affects infrastructure on Mars or infrastructure on Earth that Mars depends on? So, can we make Mars the first slavery-free planet? We can. And it's going to take a lot more work than a 25-minute talk can establish. But I hope that I've laid the groundwork not only for an interesting thought project, but also for some progress and optimism that we can build a sustainable future for future generations on Earth and on Mars by taking these into consideration. And I would love it if the great thing that future generations remembered about our generation in the Mars Society is that we made it possible for them to live in a just and fair world.
Thank you for the talk. Nobody wants to grow up to be a slave. Right? But what is the definition of slavery? If I say, I can't afford to go to Mars, I really want to go. I'll go if I agree to work for you for 6 years on Mars. Then 3 years in, I say, I hate Mars, I want to come home, but I can't. Am I a slave? What is the definition between voluntary work and slavery, where you're trying to avoid trafficking versus free will of choice?
That's a great question. I'll give you the short version, and happy to have follow-on questions if it doesn't quite suit. So the definition of slavery in the U.S., and it's actually even more stringent if you go out further afield, it gets more specific, is that basically someone is being forced to work or do activities at the benefit of another person under force, fraud, or coercion. So they've either been forced into this activity, frauded or tricked into it, or frauded into it, forced, thank you. And so you end up with categories like forced labor, forced sexual exploitation, which is different from what the law defines as prostitution and those sort of related areas. Organ harvesting is a really grim but real reality there. If you pay to go to Mars and you agree, I'm gonna work for you, and in exchange I get a trip and some lodging and air on Mars, that doesn't automatically make you a slave. If you say, well, no, I really want to go back now, this isn't for me, and your employer says, no, no going back, yeah, that starts to border on slavery. And now there's a question of like, right, but what if you signed a contract? You know, what if you signed a one-way lifelong contract? Well, we don't have any examples of that on Earth, because on Earth, that's called, for example, forced marriage is considered slavery at the UN level and by most countries.
Sign up for the military. I'm bound whether I want to be or not.
Okay, fair enough, fair enough. That is fair. So one example that might be at least interesting food for thought to mix in is that there's major controversy, not only on the sort of social justice side of this, but major controversy around prison labor in the US and what prisoners are forced to do to produce for our economy and for outside benefit. Now, you could say, well, they're in prison. This, right, like this is part of whatever program each prison wants to say it's running. But indentured servitude and prison labor are part of the definition internationally of modern slavery. So there's this serious legal question underneath that social controversy. And I think in terms of, like in terms of the military, let's say, you sign up and then you re-up eventually. But as far as I know, nobody signs a covenant, like a lifelong covenant with the military. I could be wrong. Any other questions?
Yes. You mentioned economic growth, but isn't economic growth almost by definition unsustainable, simply because you can't keep growing forever, like we've seen in 2008? Since we're having like a green field on Mars, would it not be more interesting to develop a new economic model that doesn't rely on continuous growth so much and is perhaps more one where economic size is proportional to population size, which would still allow for lots of growth on Mars, but it's also perhaps able to scale back and not just repeat things that we've seen in 2008?
Yeah, that's a great question, and the answer is yes. And I think that by nature of there being, I think initially at least multiple different stakes in the ground on Mars, you know, I don't think that the whole globe is kind of come together and travel in like a really happy summer camp situation. So I think, yeah, I think there will be different economic models, and there should be. I think we should actually work more intentionally toward that. I'm not going to take a stand on whether, you know, capitalism is the greatest or the worst or the best of all evils or what have you for Mars. I do think, though, that growth itself, if you think about tending to a garden, or you think about maintaining like the health of the human body and its ability to like, replace its cells that die off and remain healthy for either a short life or a long life, you think about, well, that's actually a version of very physical, sustainable growth. So what does that look like economically? Probably involves growth, but maybe not limitless growth. And that's, spoiler alert, if you read any of the UN documents, it's like sort of what they come to in a lot of conclusions.
We have time for one more. Go ahead.
I like this topic. First, I want to mention that normally we say the definition of the sustainability is about to develop cultural, social, and economical development to satisfy our current generation without interfering or losing the interest of our future generation. I would like to hear your perspective, how quickly and briefly, how going to Mars will kind of address this original definition of the sustainability. And the second that is that I really like the 3 pillars with your 17 variables. I like the 2 data visualization, but I would also like to know a little bit more about how you get data and how, like, what is your approach to quantify the 7 variables and made these 2 correlations. Thank you.
Yes, I'll try to get those different parts in mind. Please let me know if I miss a part of your question in responding. So absolutely, I personally love the definition of sustainability and the perspective of maintaining, meeting our needs without compromising the ability of future generations to meet their own. Part of what it means to be human and what is increasingly acknowledged at a global policy level is that exploration and growth and expansion can't stop those things from societies. And so part of going to Mars is us meeting that need for exploration, for discovery. Now, a lot of people going to Mars are trying to go there for scientific discovery as well, which will benefit us on Earth more immediately sometimes. Right? Different missions to space, different experiments in space are intended to support Earth way before they ever support Mars or future life out there. So that's sort of a double-sided, like, yeah, it's looking at us now, but it's also looking at us later. And just quick, I'm forgetting the middle part, so I'm going to jump to the end of your question about the data. So those threads, those graphics with the threads on them, those are pulled from European Commission data. And it's a graphic that you can filter. You filter their data based on what you're interested in, based on what SDG you want to look at, or based on whether you want correlation or whether you want causation. They've got all of their sources, their sort of metadata and links to everything that's available online. So I can dig into those when I create graphics like this and decide, does it suit sort of the topic at hand to include this or that when I generate that image. I don't own that data. That's publicly available EC data. I think I missed a part of your question. I'm really sorry. Okay.
Thank you so much. Very inspiring. Very inspiring. And get set up for the next speaker here. So before we bring on our next speaker, I just want to mention for the breakout rooms, unfortunately, we did not get those in the schedule that we printed out, but it is online. And I'll just announce that the first track, it will be here. Let me pull it up on my phone, actually. So this afternoon, the analog research track will be here in 201. This is room 201. The future of NASA track will be in 208. These are all the same hallway we're in. 208 is future of NASA. Biotech is 210. And Mars Technology Institute is 212. So it's 208, 210, and 212, all within the same hallway. We have signs up as well.
And right now, Ed Kite is where?
Dex Hunter-Torricke is our next speaker.
But you have, oh, I
And then
see.
Edwin Kite following him. Okay.
James, will it be the same tomorrow, the rooms, the tracks?
It is slightly different tomorrow. We're going to have the legal and political track. And again, this is on our website. You can go to marssociety.org and pull down the program itinerary on your phone. That's what I'm doing right now. We unfortunately, we send these books out for print about a week before the conference, and we always have last minute changes. Unfortunately, this year we had some snafus with the room scheduling. So unfortunately, we had to kind of do this last minute, but tomorrow it's going to be legal and political in 201. Mars against, so that's the second track tomorrow will be in this room. Legal and political. Mars against hunger will be in 208.
Or is it just on the computer?
Astrobiology will be in 210. And technology will be in 212. On Saturday, it goes back where the first and second tracks are not flipped. So it's on Saturday. Oh, okay. So I'm sorry. What I just said is not correct. So on Saturday, legal and political is 208. Technology is 210. Analog stations is 201. And the Mars Society track is in 212. We also will have on the registration table tomorrow morning a printout of tomorrow's schedule. You can pick that up as well as Saturday morning, and it'll have these rooms on it. Okay. Any questions on that? Okay. All right. Our next speaker is Dex Hunter-Torricke. Let me introduce him. Dex is one of the world's leading strategists and thinkers on AI with nearly 2 decades of experience at the intersection of technology and global power. He has advised some of the most influential leaders of our time, including as head of communications for SpaceX, where he reported to Elon Musk, head of communications for Mark Zuckerberg at Meta and at Facebook, and as Google's first executive speechwriter, supporting executive chairman Eric Schmidt. Dex began his career as an advisor to UN Secretary General Ban Ki-moon. More recently, Dex has been head of communications and marketing for Google's DeepMind, where he led the launch of Gemini, the company's flagship AI system. Dex's last day at Google was last week. And later this month, he'll be announcing an exciting new chapter in his career. Dex is a fellow at the AI research nonprofit Fathom and a fellow at the University of Cambridge Think Lab. Dex, welcome to the stage. Welcome to the Mars Society.
It's great to be here. I used to live in LA, obviously, when I was working at SpaceX, and I don't get to LA as much as I'd like to these days. So I literally arrived about 5 minutes ago, and it's kind of funny because the whole last few days I've just been thinking about Mars and spending this time with all of you, and then it's like you sometimes have to look up at the stars, but also think about LA traffic, which is really a big problem. So I'm going to start just by talking a little bit about what brought me to SpaceX in the first place. So I think, like a lot of folks here, I grew up as just a huge science fiction nerd. And, we've all got our favorite depictions of Mars and space, in the books and the movies and the things that we all love. But this is actually relevant to how I ended up working for Elon, because it was 2016. And at the time, I was working for Mark Zuckerberg, and I was living in San Francisco. And I had flown down to Hawthorne for the day to do an interview with Elon to be head of communications for SpaceX. And obviously, it seems difficult to believe now, looking at the trajectory of the company over the last few years. But at the time, SpaceX was obviously the underdog. It was the insurgent in the aerospace industry. And obviously, there are a lot of other folks and ULA and national space programs that sort of seem to have the edge on the future. And Elon had brought me in, or at least I was told Elon wanted to bring me in to manage that political and regulatory fistfight in Washington, so that you could actually get to the point where folks could be thinking, can I depend upon the Falcon 9 as my launch workhorse? And so I got to the SpaceX factory for my interview with Elon, and when I got there, they said he was running a little late. He was running 4.5 hours late, which most people would say is more than a little late. So they didn't really know what to do with me. So they said, why don't you go have a really nice lunch at that steakhouse down the street? And I thought, I'm pretty fast-paced, it's the ADHD. And I was like, 4.5 hours for lunch? I've never done that in my life. Anyway, so I went there, and I thought, right, I'll use it for some extra time to prepare for this conversation. And by the time I went back to the factory and Elon arrived, I thought I had gamed out every conceivable question he could possibly ask me about what a communication strategy, what a regulatory strategy would look like for the world's hottest aerospace insurgent. And when I got back there and I went into Elon's office, he only actually wanted to talk about one thing, which was this. He said, what does the government of Mars look like? Which is not one of the interview questions I prepared for in my 4.5 hours. And luckily, because I read so much science fiction, I ended up going back to my favorite depictions of what that far future of humanity looked like. And what we ended up talking about for the next hour is Kim Stanley Robinson's Mars trilogy, which I'm sure most of this room has read or is familiar with, and is personally my favorite depiction of what that future looks like. Because, of course, I think truly, exceptional science fiction is in fact mostly not about the science at all. It is about what becomes of us as a civilization, as people. And it's a truly exceptional series of books, and I know that's why so many folks from NASA astronauts to, West Point, grads, they all love those books and, often look at them, in professional settings, because they're mostly all about the social, the economic, the political, the geopolitical ramifications of what building an entire world is all about. And I so strongly agree with the last speaker, this is truly all about world building, and it's very complicated to build a whole new world. Now, at the time, I don't know, I was 30 years old, I was kind of an idiot. I thought, why is he actually asking that question, right? I mean, it's like, this guy doesn't like complying with regulations on Earth, and he wants to talk about the regulatory environment on Mars. It's like, it's a little bit weird. But I now talk about this all the time, right? Because apart from the fact that it's an exceptional Elon story at a time when there's increasingly fewer exceptional Elon stories, it's also one of those things which is a really clever question if you think about it. Because when we think about building entire worlds, the natural temptation, particularly for serious folks like all of you, is probably to reduce it down to the really practical problem solving immediately. There's probably a bunch of you who are thinking, I came here to hear about AI and specifically what the heck is it going to do to help us get to Mars? And we're going to talk about that in a moment. But there are a bigger set of fundamental questions and scenarios and possibilities which we absolutely have to take seriously. Because at some point this century, if Elon or anyone else who's heading for Mars succeeds in their ambition, then someone is going to have to answer that question seriously. What does a government of Mars look like? If you want to have human activity and community and maybe company activity and nations all operating on an entirely new world, how do you organize that new world? And obviously some of the things we've done in international law and other things can illuminate parts of that problem. But I promise you that the idea that we have a well thought out, structured, detailed plan for how to organize all of that based on things that are written decades ago, I've got a bridge to the future to sell you if you believe that. And so this is the starting point for what I'm going to talk about. There are things that are underway now in the world, this world, which will radically transform the nature of our path to Mars. It is far less simple than I think we sometimes think, because we all love space, we all love the idea of the story, that animating quest for humanity to reach out for another world and build it. But before we get there, we are going to have to figure out a whole bunch of other things, and that's where AI will help us solve some of them, but it will also cause us all sorts of other challenges. Now, at Google for the last several years, and I was at Google, then Meta when it was still Facebook, and then SpaceX, and then I was back at Google, glutton for punishment for the last several years. The whole time, that trajectory for the last 15 years in big tech for me has been AI getting more and more advanced. And we're not going to get into all the ways you can measure AI models, but certainly as a general principle, shocker, AI systems are rapidly advancing in their capabilities almost by the week now. Frankly, the last several years of my life have been the fastest paced, and I was pretty fast paced before. It is almost impossible to keep up with the pace of advancement in the AI models that power all of the systems and products that we are now, of course, all making use of. And along the way, something exceptional has happened in the scientific realm. We have seen a vast explosion in scientific discovery and the amazing work that begins in the lab that ends up powering all of the things that this room cares about. There's plenty of research and data points we can talk about, but some of the things that I just pay attention to, scientists using AI as a core part of their research work are now publishing about 67% more papers than non-AI using colleagues. They're getting more than 3 times as many citations. They're getting promoted faster in the lab. All sorts of ripple effects as you see what access to more capable machine power allows us to do with that vast body of data. In all sorts of the realms of science that all of us care about and which are essential for cracking different parts of the scientific challenges that stand in the way of getting to Mars, one of the most exciting is a piece of work that my now former boss, Sir Demis Hassabis, was able to achieve. He got a Nobel Prize, obviously, for this last year, which is AlphaFold. So AlphaFold, the flagship AI system from Google DeepMind before Gemini, was designed to do one thing, which was to decode the structure of proteins. And of course, proteins, the building blocks of life. If you could understand those structures, you could do all sorts of transformative things, from curing major diseases to inventing new enzymes. Absolutely, you would be able to do a bunch of things that we need to do to prepare humans to live on a planet where we will face extreme environmental challenges and challenges to the human physiology on the journey even to Mars. And after many decades, more than 50 years, human scientists had successfully decoded the structure of about 170,000 proteins, which sounds like a lot, except scientists also estimated there's about 220 million proteins. So at the pace we are going, it would take thousands of years to actually work our way through the full compendium of those structures. AlphaFold began demoing a prototype system in 2018 within Google. By 2022, DeepMind had successfully decoded the structure of all 220 million proteins. The data was completely open sourced and put online. It is now being used by more than 2 million scientific teams around the world to do all of the things I talked about. Everything from working to cure cancers, invent enzymes that can eat plastic micropollution, overcome antibiotic resistance, develop new malaria vaccines. That's what won Demis the Nobel Prize. That is a single AI system based on technology from a few years ago. And we have yet to see the full effects of what is coming. And yet I talk all the time to the world's leading researchers who are using AlphaFold now for some of those pieces of work. They have rock solid 100% confidence the first major diseases to be cured with treatments derived from AlphaFold will arrive within the next decade. One single example. And then the applications just get more and more interesting for us. Of course, using AI to discover entirely new materials, things that never existed before, which allow us to build differently, to transform the physical world around us. That is, of course, another huge area of application. This is a lab in Berkeley, which is using a different AI system, which was done in partnership with Google, called GNOME. GNOME was able to discover the single largest set of new materials in human history in a single moment. So it was more than 2.2 million new types of inorganic crystal, which of course are fundamental to everything from battery technology in your smartphone to microchips. One of the interesting things about this is, of course, they found this vast array of things, but then you had to sort through all of that to find which crystals were actually stable structures that you might actually be able to do useful things with. But again, AI is very good at sifting through those things. As we know from AlphaFold, there are now teams who are using the data that has come out of systems like that to do things such as create vastly more efficient battery technology, which I think we can all probably immediately think of a whole bunch of useful applications of that and what we're doing. Imagine if you can charge your phone in 10 minutes and it lasts all year. There's a lot of people working on that one because the same advances in that, by the way, will power humanoid robotics, which is extremely power intensive. You might be able to double or treble the efficiency of solar technology. Again, how useful would that be for everything we're trying to do? If you want another example of what an AI-assisted design process looks like, which is highly relevant to our work, then of course consider that Google is already today using microchips that were designed with the aid of advanced AI systems within Google. So this is from another system called AlphaChip. AlphaChip is able to use AI to assist with floor planning in chip design. So floor planning is literally the physical layout of components on a chip. It is very, very complex, as you'd expect. It can take weeks or months to figure out exactly how to optimize the layout of those components. AlphaChip can do it in a few hours. And so what you do in that system is, of course, you're able to do things such as optimize the shortest amount of wire length between different components, which makes your chips much, much more efficient and faster. So, in fact, on the latest generation TPUs, which is Google's fancy AI chips and what they call them instead of GPUs, on the TPUs, in fact, you're seeing power efficiencies, thanks to AlphaChip, of more than 67% over the previous generation non-AlphaChip assisted designs. So if you think about all the power requirements for all the things we want to do, that might be extremely useful. And then this is where it gets even more interesting. So it truly is staggering and kaleidoscopic when you consider the impact of these systems, because of course, AI doesn't show up on its own. None of this arrives in a vacuum. And of course, one of the things I'm sure lots of the room thinks about is quantum computing and access to those future generation supercomputers. Well, if you are able to use AI to assist with cracking all the vast number of technical obstacles in the way of quantum computing, the applications truly are extraordinary. This room probably knows quantum in much greater detail than I do in a bunch of cases. But of course, ultra precise, spacecraft navigation, building a secure internet backbone in space to assist with sending spacecraft to Mars. Obviously using the power of these enormous supercomputers to actually develop new materials to build spacecraft with, all sorts of things that could be absolutely transformative in any number of realms. And then you get to one of my favorite things, because as I mentioned, I'm a big science fiction nerd, and one of the things that I'm sure all of us have spent years of our lives hoping for and praying that someone was actually going to crack this thing, almost as fundamental a scientific obstacle as AlphaFold and the protein folding problem, nuclear fusion. And of course, Just like self-driving cars, it's always 10 years away conveniently. Every year someone will say it's another 10 years, and sooner or later it adds up. And yet, after more than 70 years of scientists trying to make commercial nuclear fusion a reality, we truly do believe we're not 10 years away. We are far closer to that today, and AI is playing a critical role in that. One of the things that we're seeing now in experimental tokamak reactors around the world is AI systems are being used to optimize the configuration of the plasma clouds inside there. If you can use AI to figure out how to optimize the magnetic coils and the voltages and shape that swirling ball, which is 100 million degrees Celsius plus, if you can do that, you might be able to create a reaction that lasts for longer and then becomes something truly sustainable. And what could we do if we have access to clean, unlimited energy, which of course, with hydrogen isotopes coming from seawater, truly would change the world? Well, I'll tell you what one scenario looks like. This is what was told to me when I joined Google DeepMind, and Demis has talked about this one publicly, and it sent chills down my spine, so I'm going to share this one with you. We were talking to someone who was about to retire, and they said, I'm going to spend the rest of my life looking after my grandkids. Tell me something hopeful at a time when lots of things don't seem very hopeful in the world. Tell me what my grandkids might do in their lives one day if you succeed in doing everything you're doing with AI and you eventually get to AGI, human-level intelligence in machines, artificial general intelligence. And this is what Demis said. He said, your grandkids will be exploring the stars. And as Google's resident spin doctor on AI, I thought, I haven't heard any other executives use that messaging. Like, come on, unpack that one for me. And this is the story he sketched out. If you were able to achieve fusion successfully, what might you do with that? You might go and solve all sorts of other problems. And one of them might be, Demis just happened to pick this one because it was top of his mind, access to water. You're probably thinking, what the heck does that have to do with it? Well, UN data tells us that by the 2050s, about 3/4 of the world's population might struggle with having consistent access to safe drinking water because of climate change, water wars, just the breakdown of infrastructure around the world. If you had some technology that could turn seawater into drinking water, you might be able to solve that problem, at least on the technical dimension. And of course, we have that. It's called desalination. It's been around for decades. It's very well proven. It's usually extraordinarily energy intensive. But if you have access to an artificial sun with clean, unlimited energy, that's not really a problem. And so what would access to water and then all the other resources that you optimize access to, that you turbocharge the world's industries and production with, you might be able to do something which is, of course, an animating part of one of the greatest, most inspiring science fiction depictions of the future, which may have got lots of you into space, Star Trek. You end up in a post-scarcity economy, something that has never existed in human history. And you have a vast abundance of resources that allows you to rebuild the world. And then you might just get to go and do the final, most expensive thing in human history, send millions of people to live amongst the stars. What a journey. It's not about making it 5% more efficient to read your PDFs on your computer, which is generally the really boring story that people tell themselves about AI. It is a story that is all about world building. It is civilizational in nature. It's a beautiful story, isn't it? It's something that would be inspiring. It's something that when people hear that, because we are all desperate for hope in so many ways, we all cling to it. I clung to it. But that's not the trajectory we're on. Our grandkids aren't going to the stars based on the current trajectory we're on. Not at all. I'm here to spoil your day. The next decade is going to be the most disruptive time in history. There are all sorts of other things happening in the world far away from the gaze of labs and AI models and all the wonderful breakthroughs in science that are in fact vastly more challenging for societies to cope with. We know right now that AI systems are transforming every part of the economy. They are having a massive impact on every job and role and organization. For certain companies, you're already seeing the impact across a lot of different jobs. Of course, millions of customer service roles are being automated or augmented before they are automated by AI. You're seeing lots of things that are pretty cool, actually. I've got a friend who's an architect. He told me all about how AI is being used to massively speed up the design of buildings. Everything from obviously being able to visualize what structures look like, but also comply with the ever-shifting maze of regulatory compliance. Behind all things seen, there are things that are much vaster and unseen, and everything that has changed our lives in the last decade of technology has been based on all of the code and infrastructure and systems that have been built. And of course, we now have AI systems which outperform 93% of programmers who are so good they take part in competitive coding contests. You are about to see a massive explosion in the ability of technologists to build all sorts of more powerful and capable systems and infrastructure, which might take us to the future. And of course, we're already seeing the impact across public services, education, every other realm of society. Well, what might that lead to? Well, it sort of is one of those things where people do just have such narrow views of what might happen. You probably think it's a lot of stuff involving officers and, sure, some people who are using Excel and doing things in that realm might have a pretty bad time if they don't adapt, except the systems reach into every realm of society, truly. I was in Los Angeles, actually, last year, and I saw a billboard on top of a construction site, and it said, "Hey, ChatGPT, finish this building." And I guess some construction union had put that up probably to make fun of this crazy hype and say, look, you can hype it up all you want, but ultimately you need some folks to go and actually build the thing. Well, may I present my good friends Construction Robotics, where they can lay 400 bricks an hour, which is 5 times faster than a human, carry massive pallets, much heavier than a human construction worker, on-site electric welding. You can tie rebar, which is one of the most time-consuming parts of a construction site, in 5.5 seconds, which is 8 times faster than a human. The average age of a construction worker in the United States is 43 years old. 10 years ago, it was 10 years younger. 80% of construction sites are behind schedule in the United States due to labor shortages, which are not getting any better due to certain things. And how likely is it, do you think, that in fact ChatGPT will finish this building? I would not bet against the system. And this is where you start to get into more and more interesting scenarios, more and more kaleidoscopic futures, because of course, we are truly terrible as humans in being able to process a truly complex world and all the rippling effects that come as each of those changes arrives in our society. And so, of course, people look at self-driving cars, the Waymos that you can take around Los Angeles now, and you think, that's pretty cool. I can get somewhere a bit faster, and it's nice because I get into the car, and I don't have to make any awkward small talk, and there's no weird music playing, and it's great. Except, what do you think will happen when self-driving cars are everywhere? And it might do things such as change fundamentally the nature of community. If you can get in a car and you don't have to drive yourself and deal with the terrible LA traffic I started talking about, then you might choose to live in different places entirely, because of course, getting in a car and not having to drive yourself means that you might find it a much more relaxing experience. You might spend an hour watching Netflix, you might go back to sleep, you might get to work immediately. You could do all sorts of things. People will just make different choices. And in the current model, most of our workers tend to live in cities and close to the center of cities, as close as they can afford it, because they know that they are going to have to base their lives around that commute. And of course, that might not be the case. If your entire business model relies on footfall traffic around your stores, or it relies upon having a certain number of people in office real estate, you might have a real bad time in a few years as that technology rolls out. Materials design, I talked all about that. Well, what if you could use AI-assisted design to build hypersonic aircraft that carry passengers at Mach 10 around the world? What would happen if you could build an aircraft, not that anyone's trying to do it right now, that moves you from London to Sydney, Australia in 90 minutes? What would happen to local identity? What would happen to local culture? What would happen to sovereignty? What would happen to the idea of, I'm a local business with a local market? What's local when the entire world is less than 90 minutes away? Sometimes things happen which utterly transform our relationship with distance. And it's happened many times in human history in the last couple of centuries. And the idea that it might happen again often seems too shocking for a lot of serious leaders to take seriously. And yet, sooner or later, the future arrives. And the thing about the future arriving is that's not some thing that's going to happen a long, long way away. It's happening really fast now. This is a photo inside a factory in China. These are the so-called dark factories, which is the final form of automation. They're called dark factories because you don't need to put the lights on because there's no human workers. You have achieved such a zenith of automation that you might be able to turbocharge all your industries with a level of precision and output that dwarfs any of the dinosaur sets of infrastructure in companies and countries that did not take the future seriously. This is the Xiaomi smartphone factory in Shenzhen, which can crank out 1 smartphone per second. By the way, that same supply chain and infrastructure can be used for making weapons. And there comes a future where a certain set of folks who took the future seriously a little bit earlier than everyone else, a little bit more seriously, might end up with such a runaway advantage that large chunks of the world which didn't take it seriously suddenly find their entire way of life under threat and the quality of life for large chunks of their population in retreat. And you might end up in a world where access to the same AI-powered systems, but plugged into a lot of other things, our social media apps, our information sources, actually becomes a way for people to discover how far behind in the race they are. And of course, this is the ancient longo moment of exactly 1 month ago today in Nepal, when a whole generation of young people in Nepal who are living in poverty were able, thanks to TikTok and Instagram and a bunch of other apps, all AI-powered, were able to discover that the sons and daughters of the ruling elite were having lives of luxury. They were the ultimate Nepo babies. And of course, these folks all got very, very angry and they burned down the Nepalese parliament and stripped the finance minister and threw him in a river. That might just happen in more places as people's lives slip away in a future where our decision makers do not have a plan for the future. And of course, in a planetary age, which I know lots of us think about because we believe in planetary ideas, everything domestic always ends up international eventually. That is the whole story of this century. You cannot contain things in one nation anymore. Everything is connected to everything else. And of course, our international system is in full retreat now. It is decaying by the day. In Europe, of course, where I live, we are facing a full-scale war in Ukraine and the first full-scale drone war with 800 drones fighting for every square mile of the front line. And what is happening right now because of international order decaying is that the world's largest military rearmament in history is underway, with trillions of dollars committed since the start of this year to a new generation of weapon systems, which will all be powered by the next generation AI systems. All of that vast proliferation of hardware and software will combine with everything else because, as I said, nothing shows up on its own. You might end up in a world where the Chinese 6th-generation fighters, such as this, shown off in January this year, as well as Golden Dome, the humongous effort that's obviously taking place here to militarize space, all become something that shifts the plane of battle to a larger, vaster scale, which rapidly exceeds the ability of our existing diplomatic structures to contain. Very simply, our ability to wage war against each other and exert destabilizing consequences for international order rapidly escalates. And then, unfortunately, because, as I said, the future just shows up, it's very inconvenient, you then run into climate change. And we don't like to talk about that anymore for some reason, but I tell people, you don't have to take climate change seriously. It takes you seriously, though. And of course, folks living in this city know about this, because that was Malibu in the first week of this year. It doesn't get closer to home than that, does it? Climate change is underway. It shows up. It is already having a massive, massive impact around the world. We know from all the data that the world's best scientists, and this is a room who loves scientists, so I'm sure you take it seriously, you can go and look at all the IPCC climate change data. It's all online to sift through, and I spent a lot of the last year sifting through it because I'm writing a book about this at the moment. And there are scenarios now with very slight deviations in Earth's climate systems where you end up in a world where this becomes the animating reality for large portions of the world. This was 10 years ago last month. The site that some of you will probably remember this, the site of this little boy, Alan Kurdi. He was 3 years old. He tried crossing the Mediterranean with his mother and his 5-year-old brother. They all drowned, all trying to escape to a better life from Syria. And of course, what is happening now is that as Earth's natural systems fail, we are seeing the impacts on communities and the ability of societies to thrive. You are seeing that anger manifest in new ways, and you are seeing nations fail. The reason why 10 years ago there were 65 million refugees in the world, the greatest number in history. Today there are 123 million, which is more than 2 world wars combined. And in a model where Earth's climate continues on the path it is following, there is an entirely plausible model where by the middle of the 2050s, you have vast chunks of Earth's croplands fail. Between 50 to 65% of crops could fail in the most dramatic scenarios where Earth's water cycle breaks down. And in that scenario, you go from 123 million refugees and displaced people to 1 to 3 billion refugees, and the entire global south essentially fails. And in that scenario, who truly believes that going to space is going to be something that you even get permission from populations to go and do? How great the anger at those who are looking to go and do other things will be, how out of touch will we seem when vast chunks of humanity are failing? And of course, these are the protests that are outside SpaceX just a few months ago, as we saw what happens when folks who should be speaking up for humanity instead choose to take the easy way out and only talk about the innovations without recognizing the future just shows up all of it together. And if those ideas that you might retreat from space seem fanciful, I often think about the images of the abandoned Buran spacecraft at Baikonur in Kazakhstan. The Soviet Union was the other space power of the 20th century, and the story of their space program ended up as a sad, rusting reminder of what could have been. Rusting away, forgotten, entire legacy of scientific leadership thrown into the abyss by leaders who did not take the future seriously in other ways. And then you come to that final fantasy, which a certain set of folks, I don't think folks in this room, but certainly there are some voices who have a notion that when things break down here, we need Mars as a backup plan for humanity, a hard drive to back things up. It's our escape plan. Do you truly believe that if your plan is to make humanity a multi-planet civilization and the planet where 100% of humanity lives fails, that is a viable backup plan? If your plan is literally to escape from Earth to Mars in that scenario, you're basically signing up for the largest murder-suicide pact in history. That is not a viable scenario at all. And so, in fact, this is my message to you, because this is a room of people I absolutely love with the ideals and the imagination to confront very big, hard truths. For humanity to be a multi-planet civilization, it's very inconvenient. You're going to need humanity. We're going to have to stand up for it. And I don't mean this in any sort of sentimental or aspirational way. I mean, truly, there's a different future on the line here. And one of the worst analogies, one of the worst lazy mental metaphors that people use about this world and what is happening is that all of this is some sort of tidal wave, or it's an asteroid heading for Earth, or it's an avalanche. It's a set of natural forces that are beyond our control. It may be tempting to look at all these things I'm telling you about and think, bloody hell, that's depressing. Guess I'll go home and buy canned goods. You know, I'll just go and think about moving to New Zealand, as if that would get you out of it. And that isn't the future. The future isn't tidal waves. It's just the future. Just the future. It's the thing we have agency over. And with our choices, with agendas that can be absolutely shaped, because of course, things that are happening today seem perfectly implausible 10 years ago. If you can actually choose a different model for how you want to run a world and build a world, you might end up in the good trajectory. You might end up in one where all those technologies, which are wonderful and might cure cancer and realign the world around us, enable a future of vastly greater liberation and prosperity for the entire world. You might be able to harness all that technology to lead to a vast abundance in resources, which does build the foundations for enabling millions of people to reach for the stars. You might plumb new frontiers of the human imagination and artistic expression, and you might find new forms of international order, because everything that happens in history always looks implausible, and yet the world has changed so much in hundreds of years. 100 years ago, most of the world's population lived under the control of European empires, and Britain controlled 25% of the world. Things can happen that are unimaginable if you have the imagination to actually think beyond that. And this is why, in the end, for me at least, don't know about you, but I think I really believe in Mars. Of course we should go and reach the stars. By the way, the other lazy message is we should just abandon space and just go and focus on everything here. As a great civilization, as a civilization aspiring to be great, we've got to be able to do more than one thing at the same time. And there is a journey to Mars that is profoundly hopeful. It is necessary. The work must continue. We don't just stop and then one day pick it up. Too much is at stake in our future. And yet, if we believe in Mars, we must also believe in Earth, that planet where we all live and all our kids live. And over the last year, I've been thinking more and more as I get ready for things I'm about to do in my career, which are vastly more interesting than all the things I've done working for Elon and Google and so on. And I've ended up reading a lot of stuff from Martin Luther King Jr. And you may think, wow, that's a bit random. Not at all, because although a lot of folks only ever reduce what a great, brilliant thinker to a single set of inspirational quotes on a poster in your college dorm room, of course, he was a profound thinker. And one of the things I love the most is he said, through our scientific and technological genius, we've made of this world a neighborhood. And now through our moral and ethical commitment, we must make of it a brotherhood We must all learn to live together as brothers, or we will all perish together as fools. And it is a mindset shift. It is a shift to a planetary vision of humanity. It is, in fact, saying humanity is not some weak or sentimental or aspirational idea. It is literally a frame of thinking and leading, which is of the highest set of ideals that any future leaders of a true multi-planet civilization, or any civilization that is worthy of the name now, must embrace. And if we do that, we might be able to carry out the hardest thing in human history and have a future human history which involves going all the way to Mars. So thank you very much. Keep going.
Thank you very much, Dex. Excellent talk. We're going to roll right into our next speaker now. Our next speaker is Edwin Kite. I'm going to pull up his slides. And Dr. Edwin Kite is a fellow at the Astera Institute. He's also a participating scientist on the Curiosity rover and an associate professor of planetary science at the University of Chicago. Welcome, Dr. Edwin Kite. And for those of you heading out for lunch, the village is probably your best bet. It's about 10 minutes walk from here. The village, you go out the front door, take a left onto the little university road. There's a few buildings down the road. You'll see an exit from the university with a white security tent. Just cross that road and continue straight. You'll be in USC Village. There's Starbucks, a bakery, a Jimmy John's, burgers, all kinds of good stuff. So that's our recommendation for lunch, the village. Okay, and now Dr. Edwin Kite. Thank you so much.
Thank you, James, and thanks for sticking around despite the offer of a Starbucks, a Jimmy John's, and other good stuff. How can we make Mars a green planet that can sustain a biosphere? This is an honest impression of a future for Mars that we might enable, but it could also be a glimpse of our own planet about halfway through Earth history. After oxygen-producing microbes have established themselves on land and started to build up the oxygen level in our own planet's atmosphere. So when can we do this? So very consistent with the last speaker, if we're going to reach the stars, we're going to have to maintain common purpose over hundreds of years. And one thing we all have in common is the Earth. As far as we know, the only planet with a sunlit ocean and an atmosphere that we can breathe. For the foreseeable future, Earth is the planet on which almost everyone will live. But if we want to extend life to Mars, extending our environmental responsibilities, then there is consensus that the first step would be to warm up the planet. And this goes from the pioneering ideas of Carl Sagan and Chris McKay through more recent ideas that I'll talk about today, like aerogels, solar sails, and engineered aerosols. So why terraform? Why turn a apparently dead planet into a living one? Well, I think that living planets are better than dead ones. For any level of technology, having two planets rather than one means that we can increase our own numbers. For some, Mars is on the path to the stars. And for more on the why and the historical and the ethical contexts, all of which are important, check out this essay by myself and Robin Wordsworth, who's a Harvard professor. But in that essay, we propose a few organizing principles for future research. Number one, very consistent with what Hoppy Price and Robert Zubrin were saying this morning. We need to do more to search for life on Mars before extending Earth-derived life to Mars. And that would include soil sample return, searching for deep aquifers, and probably some in-situ life detection experiments like Mars Life Explorer. Second, the archives of Mars climate change, so the switch from a habitable planet, at least in some times and places early in Mars history, to the apparently sterile desert surface today. That's really scientifically useful, and we need to make sure that we inspect those scientific records without erasing them. And finally, consistent with the first speaker in this session, we don't want to irreversibly commit future generations to our own choices. And so that implies that any Mars warming method should have an off switch, so that if future generations don't want to keep Mars warm, then they can revert to a cold state. So why think about this now? One reason is that we've learned a lot about Mars recently, thanks to the spacecraft missions in orbit and on the surface already. Just a couple of examples from Curiosity. So wave ripples laid down in a lake bed billions of years ago. It's a little bit hard to see, but over here you've got polygons suggesting mud cracks, wet-dry cycles, again from the era when the planet was a habitable place. And the other reason, of course, is the rapid decrease in the price of sending spacecraft to orbit. And Starship is designed to take 2 orders of magnitude more mass to the surface of Mars per landing than any previous spacecraft. So, barring unanticipated technical showstoppers, within a few years, there will be landings on Mars with 100 tons payload capacity and 1,100 cubic meters volume, which is a lot more than we have now. So just warming Mars up by itself is not enough. Any microbe to establish itself in the meltwater on a warmed Mars, the pioneer microorganism, would face many challenges. Ultraviolet light, perchlorate, salts, and there are other challenges as well. Radiation, then large cycles in temperature between day and night. And so I'm not going to talk about the problems, those problems of soil chemistry. There are other teams, and I think you'll hear from Erica De Benedictis tomorrow, who are working on that. I'm going to talk about just the necessary but insufficient first step, which is warming the planet up. So what are your options for doing that? Carl Sagan suggested just adding some dark material to the polar caps. Very elegant. It does increase the carbon dioxide level, but you can see from the thin side of that arrow that by itself, that's not going to double the amount of energy that is radiated by the surface, which is what you need to do if you want to raise the temperature to 273 Kelvin. So your main levers are local warming, greenhouse gases, orbiting reflectors, adding volatiles, and engineered aerosols. So let's talk about those. So local warming, this is mostly the Harvard group that has been suggesting this. So in a 2019 paper, the Harvard group suggested laying down aerogel. So you might be familiar with that as a space material that captures samples from the tails of comets, among other things. It's very porous, it's transparent to sunlight, and it's opaque to thermal infrared. So it's got a low thermal conductivity, so the sunlight gets in, the heat is trapped, and you can create a local melt zone underneath the aerogel. Following up a few months ago, the Harvard group used a Mars reactor to suggest a different but related local warming strategy. You basically create a bioplastic flask that lets sunlight in, helps to trap the infrared. It's gas permeable, so the carbon dioxide can leak in, but it's not that gas permeable. And so there's a pressure gradient sustained across the flask, which allows for algae to grow happily inside the flask. Okay, so what's the point? The point is that the algae themselves are making bioplastic. So then you can make another, with a 3D printer, make another flask, grow more algae and so on, and thus exponentially grow a habitat for microorganisms that can make useful things for humans, like oxygen for propellants and breathing, and food. So I'm not going to talk that much about the local warming approach, but obviously local warming is going to happen before the global warming techniques that I'm going to talk about for the rest of the talk. Greenhouse gases. So the optimal mix was figured out in the early 2000s by researchers at NASA Ames and Caltech. So they do work. The problem is that the total mass required is 10 to the 14 kilograms, which is a lot. And that's if you make the greenhouse gas out of fluorine, which is an element that's scarce on Mars. And so getting the raw material, large mass requirements, and large energy inputs all make this one a big lift. A more promising one might be orbiting reflectors. So here, what you're seeing is a 200 square meter interplanetary solar sail in flight. It's flying towards Venus. This is the Japanese Space Agency's Icarus. If these solar sails can be made more lightweight, then they can fly themselves from Earth orbit to Mars orbit and then bounce sunlight down to the surface, helping to warm the planet. And so Yuji Chikuba, who's a Stanford graduate student, has done the calculation for how many of these will be needed to warm the poles of Mars. And so this work is ongoing, but I'm pretty encouraged by this possibility. One thing that I'm listing here, more for completeness, that I don't think is a practical strategy is adding volatiles to Mars from asteroids or comets. There's plenty of volatiles in the solar system, the outer asteroid belt, the Trojans, the moons of Saturn, and so on. But the problem is that the power requirements to move enough volatiles around the solar system to significantly affect the volatile budget of Mars is beyond our current technology. It would require fusion reactors or fusion rockets, which don't yet exist. And so the option that my team is working on is engineered aerosols. So the basic idea in a proof of concept study published last summer is you add material that, like dust, is swept high into the air on Mars, so it has a long lifetime. But it's engineered to forward scatter sunlight down to the surface while trapping infrared. In contrast to natural Mars dust, which actually cools the dayside temperature, this engineered dust would warm the planet. So it's about 10,000 times more effective than the best greenhouse gases. So on a per unit mass in the atmosphere basis. It's reversible because if you stop the supply of the engineered dust, it will eventually settle, and so the planet will cool again. And you can make the engineered dust out of carbon or out of elements that are abundant in Mars's soil, such as magnesium, iron, or aluminum. But to actually make this work, you have to solve a lot of problems. First, you've got to make the feedstock, the raw material, so I'm talking about elemental carbon or metal, at a scale of millions of tons per year. Then you've got to take that feedstock and convert it into particles. Then you've got to process the particles into the right size and shape. Then you've got to release the particles and have them get lofted high in the atmosphere. Then the warming part we're pretty confident about. You've also got to understand the climate feedbacks. If you're warming a planet by tens of Kelvin, you're going to get strong water cycle feedback, strong cloud feedbacks. And finally, the end of life matters too, sustainability. You have to have the particles degrade in a well-understood way without posing any hazard to human health. So we're working on all of those. So I'm just going to show you a couple of highlights from the ongoing work. We're doing high-resolution plume modeling. And so the purpose of this is to validate in simulation that the particles get up high when they're released near the surface. So what you're seeing here is a patch of Mars that's about 1,500 kilometers across. And the color scale from blue to red is the optical depth of the engineered dust. And the sort of rotation that you're seeing is the day-night cycle, which causes a diurnal thermal tide. We've also just started extremely high-resolution simulation of subkilometer turbulence and updrafts and its effect on the plume lofting. So an important ingredient that makes this work well is that the particles trap thermal infrared, so they heat the air around them. They get hot and they heat the air around them. So now you've got a hot air balloon effect. They self-loft. So that really helps them get up high. So when Mars is warmed, the atmosphere gets wetter. And we've started doing calculations of the climate feedbacks. So the water vapor is a greenhouse gas, so that's good. But the cloud radiative effect can be either positive or negative, depending on details like how big the crystals are in the clouds and how high the clouds are. And so that's subtle, and so you need careful modeling. And the results that we're getting so far say that you get orders of magnitude more water vapor and thick clouds in the winter pole, but the net effects mostly cancel out. And so we don't get a big temperature response due to the water cycle feedback. We want to get things off the computer and into the lab. And so we've started making these engineered particles to validate their radiative properties with Fourier transform infrared. And so what you see is three different shapes. We've got rings, ribbons, and a different type of ribbon. And to more rapidly iterate between the particle design and the calculation of the radiative forcing, we have developed a new open source 1D model, which anyone can play with to look at how the particle radiative properties convert into warming. So what's the bottom line? Tatsu Nakagawa will be giving a talk this afternoon in more detail, so I don't want to steal Tatsu's thunder, but the basic idea is the energy input that is needed to make these particles will be dominated by the energy requirement for making the feedstock. So the processing steps will not be as energetically expensive. And so that means that if you know the feedstock production cost, then you can calculate how much Mars warming you get as a result. There are two caveats associated with this graph. The first is this doesn't include all the climate feedbacks. For example, we have not included the dust feedback. Also the particle lifetime here is assumed to be 400 sols, which is coming out of a GCM that again doesn't include all the processes that can lengthen or reduce the particle lifetime. But the basic idea is a few gigawatts of steady state power input gives you tens of Kelvin warming. Okay, so these are just numbers. So what you're doing is you're basically taking the 10 to 16 watts of thermal infrared that is radiated from Mars today, and you're doubling it, so you're getting an additional 10 to the 16 watts for an energy input of a few gigawatts. So this is a very good multiplier if it can be actually done. So the next step in showing that it can actually be done after Earth-based testing is precursor or test missions. So the possibility of extending life to Mars, of creating sustainable habitats and biospheres beyond Earth, I think provides fresh impetus to a lot of missions that the science community want to fly anyway. So we already want to do a deep water search. That was one of the figures in Hoppy Price's presentation. We already want to do an ice mapper. We already want better climate monitoring because our spacecraft in Mars orbit need to be refreshed. And we already are intending a soil sample return. That's the Chinese National Space Agency's Tianwen-3 mission will give us a soil sample return. And so if we want to do engineered aerosol warming of Mars, we need to validate the dispersal of the engineered aerosol, and that will require a precursor mission, which Adrian Dumitrescu will be talking about on Saturday. So what's going on here? The blue to red is our best guesses to the dust loading on Mars when the spacecraft arrive. And so the main message here is that when we get from Earth to Mars, for the next 3 opportunities, we're going to be landing in or just before dust storm season. That's not great, but it's a reality that we have to deal with for the next 3 Mars opportunities. Given the importance of lunch, thank you for sticking around. I think I'll wrap up a little bit early, we held a second Mars terraforming workshop last month in Berkeley and discussed a lot of these topics in more detail. We have a Nature Astronomy paper describing basically the readout from the first Mars terraforming workshop that I've got plenty of printouts of. So if you wish to just come and chat to me, and I'll give you a copy. But the main point is that it's been understood for over 50 years that if you want to green Mars, there are 2 steps. First, warm Mars up to allow a photosynthetic biosphere, then build up the oxygen using mostly photosynthesis. So we're working on the first step. There's been a lot of developments recently with new Mars warming methods, a series of workshops on both global and local terraforming, and our most recent results are the plume tracking simulations. So thank you very much for listening.
My question is on the second stage, so it might not be exactly what your main area of expertise is, but if you once you have warmed it and you manage to create an atmosphere, I see two problems to keeping it. One is the absence of a magnetic field, and the other one is the absence of plate tectonics. And have you, in your studies, or are you aware of how that further down the road might be addressed so that we can keep the atmosphere once it's been warmed and we've been able to form one?
Yeah, so the absence of Mars's magnetic field, so the current atmosphere loss rate is known. It's measured by Europe's Mars Express and the NASA MAVEN spacecraft. And it's about 250 grams per second, which is negligibly slow. So if you add atmosphere to Mars, that loss rate will not increase much. The atmosphere, you can think of Mars as being a kind of target for the solar wind and for the X-ray and extreme ultraviolet photons. And if you make the atmosphere thicker, then that target disk increases in area by a little bit. So you're not getting much extra, you're not collecting much extra damage. The change in composition from mostly carbon dioxide to mostly oxygen does mean that the thermosphere gets warmer, so you lose a little bit more mass, but probably only by a factor of a few increase on the negligible current rate. Okay, the plate tectonics absence actually helps you. Although you're not recycling carbon dioxide through volcanoes, you're also not exposing fresh rock. So the weathering rate becomes cation limited really quickly. So one way to think about it is if you drive through a road cut, the rocks are kind of, you have the oxidized layer right between the rock and the soil, and then you have sort of grayish reduced rock just below. So you only have a pretty limited weathering rind available to you, which could consume carbon dioxide through releasing cations followed by carbonate formation. Yeah.
Once the surface becomes saturated, you're not going to lose any more
That's right.
oxygen.
Yeah, that's right. Yeah.
Thank you.
Yeah, so there's a lot of concern, obviously, about existing Martian life and what terraforming projects would do for that. I just want to make the point that any existing Martian life is basically the survivors of a 4 billion year extinction event. And it's had a really rough time. And if we went and warmed up the planet a bit, that would actually open up the opportunity for existing Martian life to expand and recolonize the biosphere, which would actually be a very good thing.
So Chris McKay, who is someone who's thought about terraforming as a scientist at NASA Ames Research Center, has made a similar point. But I would push back a little. I would say Mars is, collectively owned, and we need to have some kind of, near global consensus to make changes on the scale of a whole planet. And in practice, you're just not going to get that consensus unless you've shown to pretty much everyone's satisfaction that there isn't life on Mars already. So that's a slightly roundabout thing of starting by consensus and working backwards. But I think in this case, you would want to check that there are deep aquifers. If there are deep aquifers, you would want to sample them to look for life. You would want to do something like Mars Life Explorer, an in situ life detection mission on ancient ice. So all of this can happen in parallel with Mars terraforming research. It is, we're doing it. But I don't think a decision to deploy, as opposed to merely do research and small scale testing, would happen unless there was scientific consensus that there isn't life on Mars today, if that makes sense.
Yeah, well, it's almost impossible to rule it out, right? Because you can always dig deeper.
Yeah.
But there's, potentially if, dormant life forms that can reemerge because if we warm it up and moisten up the planet, it's probably the best thing that could happen for Martian life in 4 billion years.
Well, it's true that if humans don't do anything, Mars will stay a desert for many billions of years. And it's already been a desert for a long time. Until the sun goes red giant, but then Titan gets exciting. By the way, there is a ring here on the front stage. I'm not sure. Has anyone missing a ring?
This is a very elaborate proposal.
No, it's not. No, it's, I mean, I don't know if it's associated with our conference. Oh, it's been there, it's been, okay.
One last question, and that is, you may have touched on this,
Yeah.
but there is this view that the atmospheric pressure of a CO2 atmosphere above basalt rock
Yeah.
auto-regulates to be just above the triple point.
Yeah.
But did I just hear you say that you didn't think you could still raise the amount of CO2 because there's no plate tectonics, so there's no more fresh basalt to weather, so there's no alkaline runoff to bring down the pressure of CO2 in the atmosphere, so we don't worry about that? We can, in fact, jack up the pressure on Mars as a CO2 atmosphere higher and higher without having to worry about that feedback cycle? Is that the point?
Yeah, so I actually just published a paper on this, just on the early Mars question, but it's all about cations. So if you want to make carbonates, you need calcium or magnesium or iron, and you need those cations to be exposed to the liquid water. So what do you got to work with? You basically got the soil there, and you've got fresh ash coming out of volcanoes. But there isn't much fresh ash coming out of volcanoes on Mars.
But there's a large amount of magnesium sulfate, as I understand it, precipitated all over the place. You have the magnesium. You don't have the alkali, which presumably would come from the weathering of basalt. But are you saying that weathering of basalt is done for the most part, and therefore the reservoir of alkali from below is saturated, so you can raise the atmosphere, the concentration of CO2 indefinitely high? Is that the point?
Yes.
Okay.
So the details matter, and if you have rivers carving canyons, then that's going to expose more cations. But if you to be quantitative, all of the valley networks on Mars add up to about 2 meters global equivalent layer of erosion, which isn't much. They're locally deep, but most of the landscape doesn't have those valleys. And so if you had the same amount of erosion on a terraform Mars that you had for the whole valley network area of Mars, that would only give you 2 meters global equivalent layer of erosion, which is not enough to draw down. Yeah.
So two things. Are you aware that JPL did a study, probably been a couple of years now, about the using the more advanced PCR methods of getting down to finer and finer levels of finding microbes and simple organisms, and they discovered after re-irradiating test systems that actually the irradiation techniques, the heating techniques they use, I should say, did not sterilize. They found thousands and thousands of different sorts of phyla of microorganisms, and the question is it possible we've already gone beyond planetary protection and seeded the surface of Mars?
Yeah, I think it's almost certain. So the planetary protection requirements aren't get the number of spores to zero. They get the number of spores down to a level where you're not going to be fooled by the Earth life that you bring with you into thinking that you found Mars life when it's actually Earth life. So Hoppy mentioned getting the Perseverance, sampling and caching equipment down to fewer than 1 microbe. That's exceptional. He didn't say anything about the rest of the spacecraft. The rest of the spacecraft's got microbes on it. All the other spacecraft got microbes on them. They aren't growing in Mars's environment because there's no liquid water. But they're probably going to hang around until radiation damage eventually scrambles them at some future point. Now, when we send people, we're going to send orders of magnitude more microbes when we open the airlock door, relative to all robotic, robotically delivered microbes, both up till now and for the foreseeable future. And so what that means is that if you want to, do a very clean search for life on Mars, you better do it now before humans get there, because you can't sterilize a human spacecraft.
Well, the second question is that's very insightful, and I appreciate all your work on this. What do you make of the blue iridescent spots that have been seen on Mars? Gale crater, Jezero crater, and some other indications of forms that appear not to be mineral formations, but actual perhaps very primitive forms of life, fungi, fungal networks, mycelium networks that are already forming on the surface of Mars that may escape detection?
Yeah, so I guess there are two things. The first is the leopard spots, which Hoppy showed briefly in his talk.
Yeah.
So these were published by the Perseverance team a couple of months ago. They are mineral formations. The question is what made those mineral formations? Now, in an Earth context, it would normally be life, but in a Mars context, you've got to consider many other explanations. And what you're actually seeing is a signal, is basically chemical reduction, which on Earth, that's normally you've got some dead cells, and that's the organic matter, and then the spot kind of grows away from from the organic matter. But you can do that in principle with any reducing mineral. So pyrite, for example, could produce that reduction spot. Now another, there hasn't been anything on Curiosity that the science team have talked about. I'm on the Curiosity science team, but for Spirit at Gusev crater, there was a detection of this sort of like digitate shape in the hot spring deposits. So these are old hot spring deposits. And again, in Earth hot springs, whenever you see that sort of digitate shape, it is associated not with the growth of a single organism, but with the sort of colonial growth of a microorganism. And that was, although inconclusive, that was taken very seriously, and it actually led to just go back to Spirit's Gusev resting place being the in the top 3 candidates for the Mars sample return Perseverance landing site. But it was ultimately not selected on the grounds that it would be putting all our coins on basically one sample instead of the much more geologically diverse site, which is what Jezero has proven to be.